Good afternoon to all the respected dignitaries, faculty members, and dear participants. On behalf of the Department of AIDS Keystone School of Engineering, I extend a warm and cordial welcome to all of you to day 4 of the Faculty Development Program. Today's session focuses on fine tuning and customizing large language models, a highly relevant and advanced topic in the field of AI. We are delighted to have with us Mr. Yogesh Murumkar as the resource person for today's session. We sincerely welcome Sir and all the participants and look forward to an engaging and knowledge-rich academic session. Before we begin, I would like Mr. Murumkar to you all. Mr. Murumkar is a distinguished CEO and corporate trainer at Bharat Software Solutions, Pune, with over 11 years of combined experience in the IT industry, professional training, and teaching. He has a bachelor and post graduation in computer engineering, and his expertise is in data analysis, data science, BI, generative AI, LLM, ML, deep learning, and NLP. He began his career with Capgemini, where he worked for 4 years on enterprise level and has handled international clients such as Barclays, etc. Over the years, Mr. Murumkar has successfully trained more than 2,500 students and working professionals in technologies including AI, Gen AI, and related tools. As the founder of Bharat Software Solutions, Mr. Murumkar leads a growing team of professionals and interns, providing development and training services while offering real time industry exposure to students and fresh graduates. His strong industry background and practical teaching methodology make him an ideal resource person for day 4 of our FDP on the topic fine tuning and customizing LLMs. Over to you, sir.
Yes, madam, please. Okay, just
तुझा लॅपटॉप आणतो का इकडे एक मिनिट.
I hope, madam, my screen is visible.
Yeah, just a minute. My screen is shared.
Okay,
Uh, yeah, your screen is visible.
visible, right?
Yeah.
Okay. Okay. Thank you, madam. Thank you for the introduction. And good afternoon, everyone. I can see some similar faces as well. Sharan Reddy, sir. Good afternoon. I seen your message as well. I
Very good
hope you
afternoon, sir.
recognize me. Yeah. So I see other similar faces as well. Anyway, fine. It's good to see many of you once again, everyone. So I think we have got some time, maybe on 2.5, 3 years. So what I will try to do is I'll try to make it conceptual plus hands-on way. Okay. I know that most of the participants are already experienced. So obviously, sharing your insights in between, that's always good anyway. Because see everyone, something like AI or generative AI or even LLM, if you talk about, all these are like evolving fields, right? Like no one can say that okay, he or she is an expert, even if maybe someone is PhD, dual PhD. It's not possible actually, because domain wise as well, you see lot of things are coming into picture day by day. Every day you see different tools are actually coming into picture. Yes, but one thing is for sure, if someone is really good with the basics, if someone knows about the uh, suppose let's say the architecture, if you talk about, let's say suppose the working of the architecture, something like transformer, here we'll be talking about how it works, what are the components, what are the different phases, and some of the other basic terminologies. So definitely one can go, one can explore and learn the things, that's possible. So I'm just trying to give you everyone an idea, because everyone, it seems, is obviously experienced in their field. Definitely, if some input is there from your end as well, it's always good even. So it should be like two-way kind of communication. I can understand maybe many of you might be in your office or college, wherever you are. But if it is possible, you can always let know. Okay, whatever it is. From my side, what I will do, everyone, is I'll just try to give you the agenda first of all. What the way we are going to discuss about the things. As the topic itself tells you, what is the focus of this particular session going to be? It's going to be fine tuning LLM models, right? And customizing the same. So it means definitely we will be talking about different techniques here, right? Maybe many of you might have heard about those names. Maybe some of you might have even used those, implemented those techniques as well. But from my end, everyone, what I'll be doing is I'll be going from the basics. Okay, because maybe some of you might be aware about few things, some of you might not be aware about few things, some of you might have already attended earlier sessions as well. So there also you might have got some idea. All the possibilities are there. But yes, I will tell you what are the learning objectives going to be. Definitely, after this session, when you will go, when you will try out the things, whatever I'll be showing it you here or during the session as well, you can try definitely. If you go, if you try, if you explore even, definitely you'll be able to understand what exactly is fine tuning, why it is needed, and what are the different ways of fine tuning the model, right? And then what are the applications in real time, and specifically, let's say if you talk about education domain, right? So most of the participants, let's say, are from engineering colleges or maybe education domain. Let's say maybe how they can utilize it for the same thing, or maybe in the research as well. Okay, so that we will go, we'll try to explore, and during that particular discussion or even definitely we'll come across different techniques. Now, the tool which I'll be using is Google Colab only, because Google Colab is something which is available for everyone. You don't have to install anything as such. Obviously, everyone will not be able to use the bigger models like on our local machine. I think everyone knows about that, right? So that's one of the main reasons why again something like online platform like Google Colab, where we can utilize GPU. Okay, so fine, we'll start the discussion everyone with fine tuning and customizing large language models. Okay, as I've told you, I'll be expecting in between, if you have anything, it is like just let me know in the chat box instead of maybe unmuting initially. I think if you put the things in the chat box, it will be good. I'll have a look at the chat box always. Okay, that way I think we can keep it as like two-way communication. Okay, that is how I think I'll be expecting from your end. So anyway, you can, I think everyone is having an access to put the things in the chat box. Okay, fine. So let's start with the discussion on LLM, everyone. So as I've told you, our topic is going to be fine tuning and customizing LLMs. So definitely I'll be expecting at least you should know about what is LLM. Okay. Or maybe what I will do is I will just try to take you through that, right? Whenever we say LLM, right? Whenever we say LLM, so everyone is using it anyway. Like ChatGPT, you are using Google Gemini, Perplexity, Falcon. Any lot of models are there. Even lot of models are there. Okay, like this, lot of models are there. So to start with everyone, to start with all this discussion, let me start with LLM itself. Now LLM has become a very common topic, right? Everyone knows about it. Whether a person is from a technical background or not, fine, everyone uses this something like LLM, right? So, or even at least they are using ChatGPT, that means they are using LLM. So they are, everyone is using irrespective of their domain. So my first question to you everyone is, those who are listening me, what do you think, all of you, how many such models are there in the market, like ChatGPT, Google Gemini, Perplexity, Cloudy, Falcon, and so on? Any idea how many number of models are there? I know it's a very basic question. Definitely, you must have come across this, but I've told you, right? Initially, from my end, you'll be able to see very basic questions, everyone. So, how many such models? Any idea? Like maybe in the chat box, you can put how many such LLM models are, by the way, available. Okay, I think I'm getting some replies. Difficult to count. Okay, Antosh sir is saying difficult to count. Fine. Many more. Many more means how many? How many, sir? 100, 200, 300, 1000, 10,000. How much? Any idea? How many such models? Because obviously most of us use OpenAI's models. ChatGPT is one of the very commonly used, right? As I've told you, Google Gemini, everyone is using. So how many such? Maybe five. Fine. Professor Sheikh Yassin is saying five. Fine. So yes, five or 10. Now see everyone, I will show you how many such models are there. You see, if I simply go and if I check out the Hugging Face platform. Hugging Face, if someone is not aware about, let me tell you, it's a platform where you can see models available. We can use the models here. We'll be using it. Now you want to see what is the count of the models even. If I go click on the models, now can you read this number even? Those who are saying 5 or 10 or 100, it is more than 22 lakhs. It is more than 22 lakhs models available. Please check it. Please check it with you. Hugging Face is a platform. Even you can go, you can also check it out here. More than 22 lakhs models available here. How to use these models? We'll be talking about it. How to fine tune these models? We'll be talking about it. I'll be showing you practically. But obviously, one needs to be there till the end. Then only the things will make sense. Okay, if you come in between and then again go and then again come, it will not make any sense. I know that you can study definitely. Everyone is matured, everyone is working somewhere professional, but still check, like, see if possible if you can attain till the end. Okay, so that I'll also be able to understand something new. Definitely everyone, right? Because everyone is experienced here. So you see all of you, obviously out of these models, some models might be very small. You see again the parameters. I think you understand. In the previous sessions, when I seen the contents, it was like they talked about transformers, they talked about different things related to LLM already. So I think you are already aware about it. What are the parameters? You see again. So if I go and if I see all the parameters, less than 1 billion, 6 billion, 12 billion, 32 billion, 128 billion, and maybe more than 500 billion. So if I go and decrease the number of parameters, even you will see this number will decrease. Okay. But overall, you see how many models are there, right? So like in our case, what we'll be doing here is we'll not be able to use such a model where the number of parameters is huge. Billions of parameters going and showing you here on the local machine, obviously it's not practical. That's why what we'll be doing is we'll be using the models which are very small. Whenever I say small, it means what? Number of parameters are less. Maybe GPT-2, right? Distilbert. These are the models even. If someone has not heard about the name, don't worry. If someone is very much new, don't worry. That is what I would say. That's why I've told you at the start only, right? Maybe the audience might be mixed up, but slowly we will go everyone and we'll talk about the topics, whichever is there for today's session. You will understand that, okay? With hands-on example. By chance, if someone is not able to do that today, no problem. You will be getting everything. Whatever I'll be sharing here, showing you here, I'll be sharing with the organizers. Okay. So you see everyone here, you can see they can solve all the tasks. Multi-model are there. Audio, text to text, text to text, image, text to image, right? And so on. Computer vision models, depth estimation, image classification, object detection, text to image to text, and so on. NLP tasks, text classification, summarizer, we'll do hands-on on summarizer as well. Question answering, we'll do everyone, right? So it comes under NLP, natural language processing. Audio models are there, tabular, other, and so on. So all these different models are even they are present. And yes, we can use that. Maybe if someone is not aware about this particular platform, let's say I want to go and I want to use, let's say text classification even. So I will go click on this. So you see for text classification, how many models are there? More than 1 lakh models are available only for text classification tasks. So out of this, which one you see, all these models are there. Just need to go click on the model and then simply click on this, or you will be able to see the code and everything. Why am I showing you this? Do you understand? Why am I showing you this one even? Because when I will explain you the concept related to fine tuning as well, when I'll explaining you the concept even, you will see some code as well. I'll be taking you to the implementation as well. And at the time of implementation, definitely you will see that something like this will be there. So you don't have to worry about the code that much because the code is directly available all of you. It is just that you need to go and you need to refer the platforms like this. It is not like that only Hugging Face is there. There are other platforms, definitely they are also there even. But yes, it is one of the very basic platforms where you can see all these models. So first point in it is not like that 5 models or 10 models or 100 models are there. You see the number, it's huge. Okay. If I click on this, it will deselect it and you will see this is the actual number. And that is growing everyone. Maybe if someone might have checked it last year, let's say, you might see huge difference here. The same number. Maybe in the coming days, this will definitely change even. That is the reason why I've told you that no one can say that, okay, I am an expert in this field. Not possible, all of you. It's evolving. But yes, definitely, if you know the necessary things, the basic required things to learn all this stuff, if you are good with that, then everything will make sense. Okay. That is why what I will do is I will just try to start with some of the basics, and then we will move to the uh, points even which we'll be discussing. Okay, like which actually we are supposed to discuss for today's session. Let me show you. These are the things even which I have been given. Actually, I hope everyone must have gone through this. You see, these are the things, all of you, right? Fine tuning and customizing LLM. So techniques for LLM customization, fine tuning, LoRa, QLoRa. These are the methods basically. One should not worry about all this stuff. Today it will be clear everyone. You will understand. You will understand along with the implementation as well. And whenever I say implementation, everyone, it should not be a worry. Obviously, see, because the code is available. I'll show it to you. In my case, what I did is I already referred all these platforms, and there I actually have a template kind of a thing ready with me that I'll share with you. So you will also be able to do it. Okay. And the good thing is that even if you are getting some error, we have the models even which are going to solve the errors. So try to understand. It's not about coding, it's about understanding the things. Okay. So we'll talk about this dataset preparation, cleaning on annotation, and hands-on we'll try to do on fine-tuning, right? As I've told you, GPT-2, if we get time, we go with Llama as well, or Distilbert also we'll try to do. And then evaluating. So how to evaluate the performance of the fine-tuned model even. Okay. LLM performance. So all these are nothing but what even these are metrics. So let's say if someone is aware about machine learning. In machine learning, what we used to do, everyone, in machine learning, all of you, if you remember, we used to check the accuracy of the model with the help of something called as R square. Do you remember R square statistics? There was something like adjusted R square as well, right? And even everyone, in case of classification types of models in machine learning, we were making use of confusion matrix, right? So with the help of confusion matrix, we were able to get something called as accuracy, something called as precision, recall, F1 score. This recall, everyone, this recall kind of a thing will require here as well. In one of these metrics for evaluating the LLM performance, even we are going to require recall as well. And even everyone, something called as F1 score. F1 score is basically, you might be knowing, it's a harmonic mean between precision and recall, right? Like let's say A and B, if two numbers are there, then harmonic mean of A and B, you might be knowing about the formula, right? 2 divided by 1 upon A plus 1 upon B. So if you solve this even, it will be like 2 into A into B divided by A plus B. So F1 score, you might recall, you might be able to recall even, it is basically harmonic mean between precision and recall. Okay. So anyway, these are the things even which we are going to discuss, right? Deployment options we will try to see, and model optimization options also we'll go and we'll try to see. So let's see. Let's try to continue with the topic now. I hope so. You are getting my point. How am I going to proceed even? As I've told you, the fine tuning and customization is basically done for LLM. So one should have an idea about LLM itself. That's why the first question which I asked you was, how many LLMs are available? Talking about small, talking about the larger LLMs are even. So you must have seen, right? The number is basically huge, more than 20 lakh. More than 20 lakhs models are available just on one platform called as Hugging Face. That's what we have seen. Obviously, every model has its own purpose. It is basically used for specific purpose only. But yes, the number is basically growing day by day. And that is definitely going to grow, everyone. Maybe after some days or some months after also, if you go and if you just try to check out this particular thing, everyone, you will be able to see that this number is definitely going to grow. Okay, this particular number is definitely going to grow. So always have a look at that. I already shared that particular link with you. Maybe someone, if you are joined late, you can also have a look at it. Okay, fine. Now you see, I'll just try to just a minute. Okay, I just try to give an overview about all this stuff here. See the session context and the motivation. So why it is necessary to go and to talk about the things like this. I want to just give you an idea about what is that motivation, what is that particular reason, what is that reason even behind discussion of all this stuff. Why it is very very necessary to discuss about fine tuning of LLM or LLM itself. So you see large language models like GPT, right? The current version is ChatGPT 5, right? Or OpenAI models, even if you talk about. Specifically, OpenAI models, even you might be knowing that they are closed source. That means their architecture or the parameters are not available, right? So, what is the context or the motivation even here? LLMs like GPT, Llama, Mistral, they are pre-trained on generic internet data. They are pre-trained on generic internet data, which is huge. Anyone, any idea? Let's say if I talk about this particular thing, everyone. If I talk about a simple model, that is this one, GPT, or even if you talk about the first one, Instruct GPT. Any idea, everyone? What were the number of parameters on which that particular model was trained? You might be knowing, right? I think you are already aware about the transformer architecture and all that stuff. And in that case, you must have discussed, right? You might have seen Instruct GPT kind of thing came into picture, right? GPT 1, 2, GPT 3, and the most important GPT 3.5 also came into picture. Any idea, by the way, for example, how many number of parameters were there on which GPT 3.5 was trained? Any idea, anyone? If not, then what I would suggest is, what I would suggest even is, I will try to talk about some basic things of LLM first, how the things came into picture, right? How something like Instruct GPT came into picture, why it came into picture, and then GPT 3, 3.5, 4, 4, 4, and now 5. Everyone, whatever I'm trying to ask you is any idea, anyone, on how many number of parameters something like GPT came, 175 billion, 175 billion, right? Someone has put it in the chat box. I hope others also might be knowing. So you see, Adrian, that was just number of parameters. That was just number of parameters, right? I think you might have been introduced to transformer architecture when you might have been introduced to transformer architecture even at that point of time only. I think you might have come across a paper, everyone, right? Attention is all you need. So attention is all you need. That was one of the papers. It was like an inspirational one, right? Or that was something from which all these things basically came into picture. So if you go there and if you check it out, even they have given all the details, how many parameters, right? What were the data source, what were the data sources, by the way. And one more point, you might have understood why it is called as large, why this LLM is called as large, and why it is called as language model. It is called as large. Why? Because it has been trained on huge data. What were the data sources? I hope you are aware about it even. The data was coming from different scrappers, right? Web scraping was basically used, right? And even that data was huge. That data was huge. And everyone, why it is called as language model? Because you might be knowing, everyone, right? You might be knowing, right? Natural language or language translation. That was one of the first tasks, everyone, which was tried, right? Natural language. So researchers or scientists tried to train the model to predict the next word, to go and to convert or to do the language translation as well, even. And they tried to communicate with the model through natural languages as well, and that's why, everyone, language model. I hope you people are already aware about that. Or by chance, if someone is not, even, maybe what you can do is, see here, everyone, this is something which also I'll be sharing. Something like this, everyone, is what I'm talking about. You see, this LLM architecture, right? So why building LLM from the scratch is necessary. So there are a lot of tools. Even one of the tools I've shown you is Hugging Face, but there is something called as LangChain as well, right? And a lot of models basically. Facebook, Llama, you might be aware about. This was one of the famous models, right? Open source models and closed source models were there, right? And Facebook Llama was one of the examples for open source models even. And if you talk about something like LLM, if you talk about something like OpenAI's LLMs, even they are closed source, right? So you see, open source means entire architecture of the model is available, right? Facebook released LLM Llama, and closed source, the models released by OpenAI, they are generally closed. It means they don't release weights architecture and so on, right? And the thing which I was talking about, even, see, is something like this transformer architecture. Okay, so at least you should have an idea about this transformer architecture and the phases. So from where it came into picture, even I think that is what something has been introduced to you people, and basically that is this paper, right? If I think you are aware about it already, but maybe by chance if someone is not, let me just tell it for them. Okay, so you might be knowing about it, right? This is the paper. Attention is all you need, something like this, right? This one. On archive also it is available. If you go, if you check it out, even you'll be able to see this is the paper, right? So this was the paper where this architecture was introduced. So what am I trying to say, everyone, is at least you should have an idea about this architecture, right? What happens here? What is something called as attention mechanism? Because when I will talk about something like fine tuning, everyone, obviously you are going to require some terminologies. So was it discussed, everyone? Is it fine, or can I just take you through this in 10-15 minutes? Can I just take you through this architecture? Those who are listening me, or you are aware about, because it will be easy for me to go and to discuss about something like fine tuning as well. There I'll be using these terminologies. In case of multi-head attention or attention mechanism, what exactly happens, right? That is something which at least an idea you should have, right? So those who are listening, okay, fine. I'll discuss about it. Just in 10-15 minutes, even I will just give you an idea. Okay. Fine. Those who are already aware about it, that is good, no problem. Right. But anyway, it will not take much time. So I will give you an idea about this architecture even, at least how the things basically work. What are the phases and how it works. Right. Those who are already aware about this, might have gone through this, that is fine, no problem. But see again, everything depends on this. When I'll talk about fine tuning as well, definitely you will come across the things, right? Definitely you will come across the things which are there related to something called as LLM architecture or transformer architecture, even, right? The PPT and everything, the code and everything, whatever it is, I'll be sharing with the organizers. Don't worry. Fine. So you see everyone, I'll just take you through that. Okay, this particular architecture even, I will just try to take you through that. So you see this transformer architecture, whenever I say everyone, there are two types basically. Again, there are some architectures where you will see there are two things, encoder and decoder. And there are some architectures where you will see encoder part is removed. Okay. So that also we'll see, right? These are the stages and all you might be aware about stages of building the architecture even. And you see all of you, this simple example is there. Okay. I'll show you the book as well, which I have referred for this, the reference book, which is really good. Okay. It is building a large language model from the scratch. You might be knowing about the author as well. I'll show you in my case. I'll show you the PDF as well. You can go, you can check it out. If it is available free on the internet, you can go check it out. Okay. Now you see everyone, this simple example, just have a look at it. What it is basically doing. Because we will be going, we'll be making use of a small model, we'll try to fine tune, but still again, you will see that this kind of terminologies you are going to come across. You see again, this is simple example where what are we doing is we are translating, let's say from English to French. So you see the transformer architecture, if I talk about how it works, even the input will be passed to the first thing, that is nothing but tokenization and all that stuff you might be knowing about, right? So it will be passed for processing, everyone, right? Whenever we say input processing means obviously the problems in the data will be removed, and then only everyone it is going to go to encoder. This is just an overview, okay? And then everyone from that something called as embeddings are going to be formed. Now what is embedding? You might be knowing about something called as embedding vectors. So what you can imagine it like again is a word represented in a vector form. Okay, something like this. Why is it necessary? That also I'll be showing it to you with the help of diagram. See everyone, let's say I have a word hello, right? So this hello word everyone is basically represented in the form of a vector. Let's say like this. Let's say 32, 0, 1, 13, something like this one, right? Something like this is going to happen. So anyway, how it actually happens, we'll try to check it out. If someone wants to go and do hands-on on that, that also will be there. Okay, that file also I'll be showing it to everyone. Fine. Now you see again, one that is passed to the decoder here. To decoder, what another thing we are going to pass even is, see, this is the input and we are going to pass the partial output to the decoder. You see this, this is an example. So the conversion of this is, let's say, dash is in base spell, something like this. Maybe pronunciation is wrong, but do you see again the partial output of this input? We are also passing it to the input as an input to the decoder as well, and the in output of this encoder also we are passing it to the decoder. Right? Again, processing will be done, cleaning and everything, and then it will be passed to decoder, everyone. And then at the output layer, you will be getting the converted output from, let's say, English to French. Just an overview. Okay. Now, if this is also not clear, even you might be knowing that for transformer architecture, there is one of the really good sources, right? For the explanation, if you see here, this particular blog, everyone, you might have, many of you might have come across this agency, right? The person Jay Alamar, he has explained it in a very simple language with a very simple example. Many of you might have even come across this. So you see, everyone, whatever the thing which I was trying to tell you, exactly same thing, everyone, you see here. Okay, you see a high level look. Let's say transformer, see, this is the transformer, right? High level look. Now we'll go and we'll dig it, how the transformer basically works. So I, what I want is, I will tell you what I want you to understand from this transformer architecture. What I will be needing, I'll be pointing it out, everyone, in between. Okay, let me just go and let me just show it to you. See, Jesus etudiant, something like this is written, let's say, and this is converted into English language. I am a student. But how? How it is possible, even? How it is possible? It means what, even? Something like this. See, let's say, okay, we are learning LLM, or we are learning something like this LLM. Okay, if I ask it, convert this into Hindi, let me see whether it will be able to convert it or not, right? ChatGPT, everyone knows, right? So हम LLM सीख रहे हैं, something like this you got, everyone, right? But what happened behind that, that is what, everyone, we want to go and we want to understand. So exactly same thing here. So what happens, everyone, see this. Whenever I say transformer, see, whenever I say this, now understand whatever I'm telling you, even if someone's already aware about it. Just have a look at it. Whenever I am saying the transformer, everyone, what happens here? You see, inside transformer, everyone, you have encoder and decoder. Now, do you understand whatever I was trying to tell you, all of you? Exactly same thing, encoder and decoder. Now, what I'll be doing is, I'll be showing you what happens in inside encoder first. I'll show you in my PPT, and then I'll show you the code as well, so that it will make more sense. Those who want to go and execute that code later on, definitely you can. But you see, everyone, this was the input. It was passed to encoder, and then whatever the encoder is going to give, that is actually passed as an input to the decoder. That is actually passed as an input to the decoder, right? Let me just clear. Someone is trying to write on the screen. Fine. Now you see, everyone, here this is the input and this is the output, but in between, what's happening, all of you? In between, as you can see, there is something called as encoder and there is something called as decoder, right? Now we want to understand how this is going to work here. So now try to understand where I see many people are confused, right? This encoder, whenever I say, everyone, inside this encoder itself, they have six encoders, a stack of six encoders, I can say. How many, everyone? Six. One, two, three, four, five, six. Now this six number, is it fixed? Can it not be more than that? Yes, definitely, it's possible. It's possible, even. But again, attention is all you need, paper, right? There they have used this one. So whatever the number of encoders you have, exactly same number of decoders also, everyone, you will have here. Try to understand that. See, even though it is written as encoder and decoders, but how, why it is encoders or decoders? Because they are multiple. It's not only one. So what's going to happen, everyone, is whatever the input which we have actually here, that input will be pre-processed and then that will be passed as an input to the first encoder. Then the output of first encoder will be passed as the input to the second encoder, third, fourth, fifth, sixth, and so on. And then it will go here. And same thing is going to happen here as well in case of decoding, and finally you will be getting it. But now we want to understand what happens here inside these encoders. See, first thing is what? Input, output, and in between transformer architecture, right? your LLM, which makes use of transformer architecture. You might be knowing everyone, right? You might be knowing that what were the limitations? What were the limitations when we talk about something like machine learning? Then there came something like deep learning. Then in deep learning, everyone, you are already aware about something like artificial neural network, convolutional neural network, and recurrent neural network. In machine learning, supervised, unsupervised, semi-supervised, and the most important, reinforcement learning. Okay, this one and mostly this one even are an recurrent neural network, you might be knowing, right? There was a loop. There was a loop in that case. So then basically there was a limitation. It was able to predict the next word, but again, the context it was not able to take into consideration, or range dependency. It was not able to take care even, and that's why there came something like LSTM techniques. Then there came by LSTM as well even, and then some other models as well. They came into picture. And then in 2017, everyone, there came transformer. There came the transformer, right? And what is that secret? What is that recipe or the secret of the transformer, everyone, which has made it really very, very famous? Or we why are we talking about something like this one, everyone? There is something called as attention mechanism, right? So this is what I want you to understand, everyone. Attention mechanism or self attention, we call it as. The basic reason I can tell you is that to have control over the range dependencies, or to take the context into consideration. I will show the examples here. Let's see if I have an example. Let's say Sachin is an Indian player and he likes to play cricket. So he refers to whom? He refers to whom? Sachin or cricket? What? Right? So something like that. Even the context was, yeah, earlier models were not able to take that context into consideration, and then they were not able to generate by taking into consideration that context. They were not able to generate the next word, next sentence, and so on. So that's why transformer came in picture. It was in 2017, but the basic idea behind transformer ever is nothing but attention mechanism. So that is what I will just try to tell you the mathematics behind that, the working very simple way it is given every year. So you see input, encoder, decoder, and inside encoder, do you see? This is what I was telling you. Inside the encoder, everyone, do you see here? We have 1, 2, 3, 4, 5, 6. Now, what I've told you is it necessary to have only 6? It's not. It's not necessary, everyone. But again, the paper, right? The paper which I've told you, attention is all you need, which everyone is aware about. It's very famous, right? You might be knowing it in just in 3, 4, 5 years only. It has got more than 100 citations, right? So that research work, which was that paper which was written by 8 people from Google Brains, even they also did not think that okay, it will be used for so many other use cases as well, other than predicting the next word, or other than just going and converting from one language to another. But now you see there are a lot of other things actually coming into picture, because after that as well many people came into picture in 2020 and so on, even. Okay, so you see all of you, as I've told you, input, encoder, decoder. But when I say encoder, inside that only you have 6. They are actually stacked on top of each other. Here also you can see, right? Now, so it means my input is going to go through this thing, everyone. Encoder, and then it will pass to the decoder. And after that, all of you, if you see, whenever I say encoder, now inside encoder, see what is there? Inside encoder, then there is attention or self attention. What was the use of self attention, everyone? Self attention was actually used to find out the context of one word with respect to some other word in a sentence. I hope you understand the context meaning. Earlier, what used to happen even in something like recurrent neural networks and the earlier models, they were able to predict the next word, but the context was not taken into consideration. The context was not taken into consideration, and that is why, everyone, something like attention mechanism came into picture, right? So you see now, everyone, whenever I say one encoder, everyone, what's there? Self attention and feed forward neural network. And now I think everyone understands what exactly is feed forward neural network. That's why, everyone, when you people might have learned about something called as even generative AI LLMs as well, it is nothing but what? It is making use of neural network only. Feed forward neural network, everyone is already aware about. Something like this we have been actually coming across many times, right? Feed forward neural network, right? Forward propagation, backward propagation, and all that stuff you are already aware about. So the point is very simple, everyone. Whenever I say one encoder, inside one encoder, what do you have, even? The input will be passed through something called as self attention first, which will take care for context, meaning, and then that will be passed to the feed forward neural network inside one encoder, everyone. Now what happens in case of this? Let's see. So you see encoder, it will be passed to self attention, and inside encoder you have self attention and feed forward network, and inside decoder also you have self attention and feed forward network, everyone. But along with that you have something called as encoder decoder attention, right? Why is it used even? It helps the decoder focus on relevant parts of the input. Relevant parts of the input. Relevant part means when I say Sachin is an Indian player and he likes, so he basically is referring to Sachin, right? So they are more relevant. He and Sachin, they are more relevant even. So this encoder decoder attention is something which will take care for the relevant parts of the input sentence. Try to understand. And that also, if someone doesn't understand, everyone, you can always go. The link I already shared with you, right? You just go here, and if you check it out, everyone, you'll be able to see that he has actually given sequence to sequence models, how basically it works, right? Animations and all that stuff, everyone is given. See, I know that maybe those who are already aware about something like this, fine. But many people have seen that they are not aware about the basics, because once you are aware about these basics, everyone, everything you will see is really interesting, and it's straightforward basically. It is just that you go, you check out the examples, and you will see, you will be able to understand these things, right? So you see, everyone, this is also something which he has given, sequence to sequence models, how they used to basically work, what was happening in that case. You can always go and you can always check this out. Okay, we'll not go into the details of this stuff even, but yes, if someone wants to really go use this, maybe in their projects, in the research, or maybe if you want to go and use it for any kind of a reason even, right? So you can go and you can check this out. And then I told you already, anyway, we already have a lot of platforms where we'll be able to see the code and everything, right? So I'll also be showing it to anyway, which will not take time. Okay. So you see here now, the only difference is that inside encoder you have self attention for feed forward, and decoder you have self attention feed forward. Along with that you have encoder decoder attention, which is going to help the decoder focus on relevant parts of the input sentence. Right. Now you see again, bringing the tensors into the picture. So fine, clear. Transformer is there. Whenever I say transformer, so there is something like encoder, decoder. Inside encoder, you have six encoders. You have basically six encoders, and inside decoder again you have stack of six decoders. And inside encoder and decoder, what is there? Inside encoder you have self attention and feed forward, and inside decoder you have self attention, feed forward. Along with that, encoder decoder attention, which will help focus on relevant parts of the input sentence. And now everyone see this. This is a simple example which he has given just to understand the working. We will be coming across, everyone, something called as some matrices will be coming across, and we will be going and we'll be playing with these matrices when I'll talk about something called as fine tuning as well. So you see all of you, x1, x2, and x3, right? I am student, something like this. So this is basically input. We want to convert this into, let's say, English language. So you see, every input will be represented in the form of a vector. Whenever I say vector, you understand, it will be in the form of numbers. Vector, you understand, 1D array is a vector, right? So you see, everyone, now what this will be done. This vector format embedding, vector embedding. If someone is not aware about vector embedding, you just go and refer whatever I'll be sharing with you. That also will be clear here. Okay. So you see, whenever you go, whenever you check out the input, this input will be converted into embedding vector format. Embedding vector. At the start only I have given an example, right? One word is there, that word will be represented in the form of a vector, everyone. In a very layman, in a very basic way, everyone, if I want to talk about, see, let's say a word high is there. Now high word, let's say, is represented with these numbers, let's say 5, 6, let's say 8 and 9, right? And let's say there's another word, let's say hello. There's another word, hello. Okay. Now hello also will be represented with some vectors. Let's say 8, let's say 7, maybe let's say 9, and let's say this is, let's say, 12. And let's say, everyone, there's a word called as a cat. Cat. Now cat word, everyone, you see, let's say it is represented as 80, 60, maybe 72, and maybe let's say 21. So you see, everyone, these two vectors are having very closer values as compared to this vector. It means what, everyone? It means they might come in same group, same cluster. That means they are closely related as compared to this one. Okay, as compared to this one. Are you getting my point? So something similar here, but this thing I already shown in the code as well. uh, Maybe at the end, if you have time, I'll show it to you. Otherwise you can just go refer, I'll show you. In my case, I'll show it to you, which are those files and all that stuff. Okay. But yes, something like this. So that, see, what's going to happen is when the input is going to come, when the input data is going to be passed to the LLM model or transformer architecture even, obviously it will be pre-processed. Whenever I say pre-processing, it means what? It will be cleaned. Unnecessary tag will be removed, right? Commas, dots, stop words, everything. You are aware about all the transformations and pre-processing. All those things will be taken care of even. And then it will be converted into vocabulary. Whenever I say vocabulary, so tokenization will be done after that. Pre-processing, tokenization, and then vocabulary will be formed. Tokenization is nothing but what? Your data will be converted into tokens. Token, let's say a word, and then each word will be assigned a number. Combination of number and word is nothing but vocabulary, and then from that vocabulary, everyone, embeddings will be formed, like I show you. So it's basically a embedding vector. It's basically a embedding vector. Okay, and then that will be passed to self-attention mechanism, and then everyone will be getting other vectors like z1, z2, z3 for each word, and then those will be passed as input to the feed forward network. So where it is happening, everyone, inside one encoder, only inside one encoder. And now you see the next picture, you see, let's say thinking is the word. Okay, embed, it will be converted into embeddings, embedding vectors. It will be passed to the self-attention mechanism, and then we will get something called as z1. How are we going to get z1? We'll talk about it. It's just a score. Okay, and then that will be passed to the feed forward neural network. This is for first encoder, and then whatever we are getting from the first encoder, everyone, which will be passed to the second encoder. You see, and again, same thing, attention mechanism and feed forward network, attention mechanism and feed forward network, right? And you see again, next thing is this particular thing, right? Now, this, the sentence is like this: the animal didn't cross the street because it was too tired. Something like this is, this was the sentence. So it was basically converted into tokens and all that stuff even. And then which word is mostly related to animal, you can check out. Darker the line, it is mostly related. And if someone wants to go, see, this was the sentence: the animal did not cross the street because it was too tired, right? So that self attention at high level, it works something like this. I've told you, right? The range dependencies or the context it will take into consideration, and then it will give you the most similar word to the word which you want. For every word, it is going to find that out. And everyone, see now, if you want to have a look at this, you see here, they have given a link here. If you just go check this out, even you will get my point. Even with the animations and all that stuff also they are given. You see this, you really don't have to do anything. They have given the code and everything. It is just a matter of spending your time and understanding the things even. Obviously, it and try. You need to do. Okay. So we were having some sentence even. We were having some sentence, and now you see what it is going to do is it is just going to give the importance. You see it in the same thing. You see the animal didn't cross the street because it was too tired. And now you see everyone, layer. Whenever I say layer, so how many layers are there? 6 layers of encoders are there. Now, this is how it is even. It will make sense step by step only. So if I talk about first layer, zeroth layer of encoder, and if I am talking about only input or output or all, so I'll talk about all. And now everyone see, if I go and if I check out for this word, which is the most relevant word, for this one, for this one, for this one, for this one, and so on. So basically, these are tokens. I've told you, token can be a word or a character. Now, if I go to the next layer, even that means next layer of encoders. Now, which one is the most closest word to this, and so on. So it is basically giving us the idea. And then when we go to the second one, again it will be more clear. And then third one, fourth one, fifth one, and let's say fifth one. And now if I go and check out even, I'll be able to see the animal. So it will tell me which is the most relevant word. So that it will help us to go and to predict the next word by taking the context into consideration, not going and randomly predicting something. That was the limitation in earlier models even. That's why I've told you, machine learning, deep learning, in deep learning, ANN, CNN, RNN, RNN limitations, LSTM, by LSTM, other models were there, and then transformer, right? Attention is all you need. And in that as well, they actually came up with a simple model, instruct GPT. Instruct GPT, everyone. But you see, if someone wants to go and check this out, they can. You see, other words are not much relevant to this one even. You see this for, so the animal, let's say if I check animal, or let's say they have shown in it. So it is referring to which particular word even. You can see this. Even we can go and we can find out the percentages and all that stuff. That's also possible. So my point is very simple everyone here. If you just go check these things out properly, the things will be more clear. Okay. Now self-attention in detail. Now you see, this is something important. I told you, right? I'll be pointing out which is the thing which we are going to require even in case of fine tuning as well. So again, this is what I will require, that you should know this. You see again, simple thing. Input, let's say, is thinking and machines. Or you take any word, let's say only one word. Okay, let's say only one word you take it in, only you take thinking. Let's say thinking is the input. Now what happens in case of self attention mechanism or attention mechanism everyone is, there are some vectors or matrices which are created. See this, w, q, wk, and we have one more even, that is wv. So basically this q is nothing but query. Remember this k is nothing but key, and this v is nothing but value. Okay, generally transformer architecture itself takes time everyone. I'm just trying to give you some idea with the expectation that maybe in the previous session you might have seen something like this. Okay, so you see everyone, query, key, and value vectors. Vector, I told you it's like an array only. So what values are going to be there here even, very basic question, but let me tell you, they are random. If someone is aware about neural network, right, I've told you, if someone is aware about neural network, what used to happen in case of neural network everyone, there were weights, right? Those weights also were random initially. Exactly same thing here. Here also all the values which will be here even, they'll be random. So what's going to happen now everyone is, this particular thinking word, or whatever the input data it is pre-processed, it is cleaned, it is converted into tokens, and then from the tokens you will be getting the numbers. Tokenization will be done, so you'll be getting vocabulary, and then you'll be getting embedding vector, and that vector is this. So this is our data everyone. So what is going to happen is, this will be multiplied with this query vector, and once this is multiplied with this query vector everyone, you will be getting this q1. Are you getting my point? Exactly same thing is going to happen for others as well. So what we got even is, we got queries, we got this one, this will be having random values. So exactly same thing is going to happen with others as well. X2, right, you will be getting wq, and from that you will be getting q2. So you see here, and same thing is basically shown here. Okay, even you can go and you can check it out. Okay, you can check this out. So how are we getting q1? X1 into wq, you will be getting q1, and then we have again x1 into this wk into, you will be getting k1, x1 into wv, we will be getting v1. This query, key, and value vectors will have random values initially, right? What are query, key, and value vectors everyone? That I've told you, they will be having random values. And now you see everyone, the input was this, it is converted into embeddings. I've told you embedding is nothing but just a vector representation. Then query, how we got q1, everyone, I've told you, input into this, you will get q1, right? So we basically got q1, and then everyone, whatever we have, k1 and v1, how k1 and v1 again created again, this into this orange color key vector, you got k1, and thinking this vector into this value vector, you got v1. So what we are going to do next is, we are going to multiply this q1 into k1, and we will get one score given. You see, 1 1 2. And then what we do is, this q1 into k2, this one, another words, key, whatever we got, we are multiplying with this q1 with K2. So we got another score, 96. What is the meaning of this even in simple words? It means this thinking is more similar to thinking as compared to machines, right? It is more relevant to thinking only. That's the meaning. And then once that is done even, what we do is, we apply some mathematics, we divide by 8, whatever the number which we have got, we are going to divide by 8. Let's say 112 divided by 8. Again, why 8 everyone? Because they have used the size as 64, and we are going to take the square root of that. Okay, that's also given here again anyway. And then once you got 64 even, we apply softmax function. I hope you are aware about activation functions. So once we apply softmax function even, and then you will be getting, you will be summing up everything, and you will be getting this Z1. So what is this Z1 even? This Z1 basically is something which I was talking about here. You see this Z1. I told you it requires some patience, definitely. Okay. So you see Z1. So this is how everyone we are going to get this with the help of query, key, and value vectors. This is in short about transformer architecture. They have given you other things as well. Same thing they have basically mentioned here. You see, x into wq, you are getting q vector. X into wk, you will get k. X into wv, x is your input. But obviously only one input is not going to be there. There are a lot of words. Lot of words are going to be there even, right? And see, mathematical representation of the attention layer they are given in one line here. Whatever the query into key and into value, the result of that multiplying, we are getting the square root of that, 64 dividing it by 8, you can say, multiplying with the value vector, and then we are getting z. Same thing whatever I've told you, You go, you spend some time. Those who are not aware about, those who are already aware about it, that is very good, no problem. Okay. And now you see again, this will be again the same thing. See, attention head 0, attention head 1, 2, 3, 4, 5, 6. It is going to be repeated. Try to understand that. It's not going to happen only for one word. It will happen for all the words, all the tokens, and that too multiple times. Because attention mechanism, in short, what it does, Rivan, is it is helping you to go and to find out the relation of one word, considering other words as well. So it will basically take the context also into consideration. That's why something like this is basically done. You see, Z0, Z1, and so on. Different attentions are there. And finally, if I want to show you something like this, the summary, if I want to tell you, input, we have wq, wk, wv, we get q, k, v vectors, we get 0 z from that, and then we basically go and try to pass it to the another encoder, right? And then we'll be getting the another output vector, you can say, and then finally the data or the word, right? And you see same thing, whatever I was showing you, it's basically shown here. Even the link is also shared, you can go, you can check it out here. Okay. So you see everyone, something like this is going to happen. So encoder, it will be passed to the decoder, and positional encodings and all that stuff, even if you want to go and check it out, you can, or maybe you might be aware about it. Okay. So they have given you all this stuff, all of you have a look at it. That is in short about something called as transformer architecture. By chance, if someone needs to go and to refer my PPT for only for transformer as well, even I will give it to you, no problem. I'll share this with the organizers. Okay, you will be able to have an access of this. Don't worry about that. You see, here I shown you everything. What is tokenization, right? And the code as well basically shown, but obviously that time will not be sufficient. So you see how the tokenization is going to happen, right? Encoding, decoding, how it is going to happen, how to remove special tokens and all that stuff, right? It is given here. Byte pair encoding, which method is good, how it is good, basically predicting the next word. Everything is basically shown. See everyone, this is called as token embedding. I've told you, right? Every word will be represented in the form of vector. And diagrammatically, if I want to show it to everyone, you see, cat, dog, and puppy. Let's say cat and dog. They are more related. Why, everyone? Because the angle between them is small as compared to angle between cat and puppy. And angle between cat and jacket is again larger as compared to this one. So again, there's a mathematical equation as well. If someone wants to go and check out that in detail, that's also possible. But yes, everyone, the closer words will be in the same cluster as compared to other words. So see, these words are very close to each other, or the angle between them is very less. That's why they are in the one group, one cluster. Okay. So again, anyway, that is also shown to you, all of you, and all these examples are shown basically. And see, this is basically token embeddings or vector embeddings. Dog, cat, apple, banana. So dog and cat, you see the numbers are more or less same. They are very much near everyone. So number between dog and cat, if you check it out, they are very much near to as compared to apple. So that means what? Semantically similar words should have similar vectors, or at least similar vectors. You see, apple and banana. You see the vector values are somewhat similar. So that's how it is written. Okay, that's how it is. And diagrammatically also it is shown here. If you want to have a look at it later on, you please have a look at it. Same thing. Okay, again I have shown you here as well. Some, and this is what I was talking about even. Multi-head attention or attention mechanism. Exactly same thing I was trying to explain it to you. Okay, and then it will make basically more sense. Okay, so have a look at it. I've shown my hands-on notes as well here. What happens in normalization, that is also one of the steps in case of transformer. You can have a look at it. Dropout and all that stuff you might be aware about, right? Fine. Now you see everyone, here in this case, as I've told you, this attention mechanism and everything, everyone, if someone wants to go and check this out, text pre-processing and all that stuff, I'll just show you everyone, because this will make more sense. You see, if someone wants to go and check that, here I have shown all the steps of pre-processing, right, and embedding with the help of a dataset called as IMDb dataset. You might be aware about IMDb dataset, right? It's a movie review dataset. 50,000 number of records are there even. So you see, there are reviews, there are basically reviews and the sentiments, whether the sentiment is positive or negative. Something like this basically is shown. So the first step, data cleaning, data pre-processing, everyone, right? So all those things basically shown here. Converting everything into lowercase, removing HTML tabs, removing URLs, punctuation handling, right? So all this stuff everyone is basically shown. Chart conversion handle. So many times people make use of some acronyms, right? AFAIK, that means as far as I know. So instead of that, what one can do is one can actually create dictionary already and then just train your model accordingly, right? or just get your data accordingly. Incorrect text handling, stop words, right? NLTK, SciPy, if you want to go, if you want to use, right? Spacey library, by the way, not SciPy, Spacey library. And tokenization here, you see, I am going to Delhi. So this will be converted into numbers. First of all, tokens like this, and then that will be converted into numbers even. That's also basically shown here. Okay, have a look at it. If you also go, if you run it step by step, it's very simple. If someone is aware about at least basics of Python, they'll be able to understand this particular stuff. Then stemming, lemmatization, right? And stemming techniques are also there. Different techniques are there even. So lemmatization is one of them, and stemmer is also another, right? You can use any of these things. Okay, so this particular thing is basically shown even, which is basically first step. Whenever we talk about something called as transformer architecture, before passing the input to that, we do text preprocessing, right? And then representation in word embeddings, that vector embedding, everyone, whatever I was talking about, right? So maybe this kind of techniques you might be aware about, bag of words and all that stuff, right? Generally we come across this kind of things in machine learning as well even, right? TF IDF vectorization also, if you are aware about, that's also shown. Have a look at it later on whenever you have time. Now, third technical one, as I was talking about, that those vectors, right? Vectors that, okay, cat and dog or cat and puppy, the vector values will be more similar. So how it is possible even? So one of the very important technique called as word to vec is basically shown here. So I would suggest, even if someone is already aware about all this stuff, just go check out this particular thing with hands-on example, everyone, and then go and then try to read about the things. It will make more sense. So you see here, I think there's one diagram. If I can show it to you, you will get my point, what exactly I was telling you. Or otherwise, I will have to run, I think. Okay, I will have to run each and everything. Anyway, or just a minute, just a minute. See, what I will do is, I'll just show you only this method even, okay? Only I'll just try to show you this one, word to vec. So whatever I was talking about, uh, the representation of the data in the vector form. You see, what I will do all of you is, I'll just use Google Colab. Okay, just a minute. I'll go to Google Colab everyone, and I'll just show you one thing here. Vector representation. Okay. Later on, uh, I already have all this stuff in proper sequence even. So later on, definitely you can do it. But if someone wants to also do it along with me, open Google Colab everyone and just check this out. Because see, going and explaining the things theoretically will not take much time, all of you. Okay. So just a minute. I hope everyone knows about this. I'll change the runtime to T4 GPU. Just say okay, save it. Okay. So that T4 GPU is what I'm using, everyone. Or once it is done, then fine. I think it is connected, and now you go, you run it. Okay. I will have to install this, something called a GenSim, everyone. So you also check it out in your case, all of you. So you see, GenSim is a library, everyone. This particular library is what we are going to use here in this word to vec. Okay, I will have to simply go and install it. Anyway, I think it will take much time. But anyway, I'll just try to take you through this. Yeah, I'll have to do pip install and all that stuff. Those who want to go and run it, you can definitely see something like this. I can do. First of all, we finish our stuff, everyone, and then we'll go with this. Okay, you see, Google Colab is something everyone which always suggests us. Okay, so let me go, let me run this. Okay, and after this, if you go and if you just try to run the commands which I have shown it to everyone, everything will run. This is what, everyone, what am I trying to show you is, I'm just trying to show you vector embedding. Okay, now it should run because NumPy pandas fine, it should be there. You see, it is running. Okay, and NumPy and pandas, why am I using it? Because I'll be just going and loading some data. So I'll just try to add some cells here, and okay, you see, GenSim is what they have installed anyway. We also installed it. So let me see if we will be able to run it or not. Sentence tokenization, simple pre-processing, everyone. I'm just loading it from those packages. Okay, those packages are by default present. By chance, if someone is able to do it along with me, you can also try it. Okay, and now you see again what I've done is, okay, I will have to use the data anyway. So you see everyone here in this case, I have imported NumPy Panda Gensim and OS, right? And sentence tokenization is what we are doing everyone. And then all of you, here basically we are using some data. So I will have to go and I will have to get that particular data as well. Okay, so something like this. Just a minute. Okay. The thing is that even we'll have to get the data actually. That data is not there. So I will have to go and check that file as well. You see? So anyway, if we get time, then I'll show it to you because I will have to go and I will have to upload the data. And if uploading data itself is going to take time, see this one. If this will take time because it is more, right? You see, 50,000 number of records are there. Anyway, so what I will show you, see, what we have done is here, finally, I've shown the representation, how the vectors basically look like. As in people generally, they are not able to visualize it. That's what we have done even is, we have basically represented the data in the vector form with the visualization. So here one library is used. If you are really getting my point even, plotly.express. Matplotlib you are aware about. So we have used something like that. Okay. Which will show you a really good idea how your data looks like in multi-dimension. Anyway, later on you just try to check it out. But in short, what is this step all about even? This is just going and cleaning, pre-processing, and then converting into tokens and then embeddings. And then embedded data everyone, we are actually passing it to the encoder, and the encoder first step is what? Self attention. Okay, so all this stuff is shown even later on, you go, you check it out. But anyway, whatever I wanted to tell you, I think now it is clear to you. At least some idea you must have got even, right? Transformer, all of you, is that clear everyone? Whatever I'm talking about, the thing which I've discussed about transformer, I hope you got my point. This particular thing everyone, whatever we have discussed here, this one, what is query, what is key, and what is value. Everyone, what is query, what is key, and what is value. How basically these things work. At least, do you know, or is that clear, everyone? Those who are already aware about, or is that clear, all of you? I was just trying to tell you what is query, key, and value vector and how they are basically used in case of self-attention mechanism, which is used in transformer architecture, and transformer architecture is basically used by LLMs. So those who are able to hear me or those who are listening, okay, I hope that is clear to you everyone. So what I will do everyone is, I'll just try to show you certain questions based on that. Let me see how many of you are there. Let me see how many of you are actually listening me, or how many of you are getting my point. Okay, I can understand maybe some of you might be in office somewhere, whatever it is, but those who are there, I hope they will be there till the end. You see, everyone, these questions, I think only 7 questions are there based on our discussion, whatever we have discussed related to transformer till now, or whatever you know about transformer even till now. Based on that, these questions are there. I would request at least scan this QR even and just check out. Yes, Prashant sir. So can you just scan this and others as well? If you are able to get my point. Now what I will do is I will directly take you to the PPT, and then we'll go and we'll do fine tuning of the models, simple models even, which are basically trained on very small parameters. That is what we are going to do. So scan this QR even, those who are able to hear me, and just give you a real name. Okay. Just scan this QR with your mobile phone even. Okay. Out of 200 and like almost like 200 participants are there. So I can see 3 participants have joined. Others, just scan the QR, or if you are not able to scan it, then go to www.kahoot.it and then just enter this pin 9750278. Okay, maybe I can wait for 2 3 minutes or even. If you join, if you try to answer, then I will also get an idea that okay, fine, you people are there and you are listening me, and either you already know about transformer architecture and other basic things, or you are able to understand whatever I was trying to tell you till now. Because then only it will make sense again, okay? Otherwise, it is URL is this one, sir. I think see www.kahoot.it. This is the URL. You see, this is the URL. You go to this URL and just type this game pin 9750278. You will join this. Antosh sir. Are you getting my point? www.kahoot.it. Just type that and enter this URL, sir. 9750278. Sir, I hope you got my point right. Okay. Fine, everyone. I think 14, 15 people have joined anyway. Okay, fine. Fine. I think maybe if some people are not able to join, that's not an issue. At least, fine. 20 people have joined. That is fine. I can see 18 have joined. Anyone wants to join, everyone? Otherwise, I'll just wait for a minute and then we'll start. Anyone wants to join? Okay. Nickname means Prashant sir, give real name. Bhumika madam, link is what? You go to this www.kahoot.it and then enter this game pin 9750278. Bhumika madam, you got my point, right? www.kahoot.it, you go to this. And then, so nickname you give whatever nickname you want to give, Prashant sir. Let's say give your name, sir, Prashant. Give your name. Whenever it is asking nickname, just give your name, sir. Yes, yes, Radhika madam, give your nickname. I would suggest give your real name. Give your real name. Okay, give your real name. So I shared the link in the chat box as well, everyone. Go there, click there, and simply click on this. Anyway, fine, no problem. If someone is not able to join right now because of any reason, we will have the quiz at the end as well. Don't worry, okay? But this is just to get an idea, everyone, how much you people are able to understand or already aware about at least the basics of transformer and LLM. Okay, no issues, everyone. Those who are not able to join right now because of any reason, no problem. You can make sure that next time also you join. There'll be one more quiz which will be there definitely based on all our discussion, fine tuning and everything. So we'll have to talk about those things as well. Okay. So Arian, what I will do is I will close this and I will start now. Okay. Those who have not joined, at least have a look at the questions which are coming on the screen. Everyone, at least have a look at the questions which are coming on the screen. So let's go. Let's start. Everyone, you will see first question based on transformer, and you will see four options. Whatever the option you feel is correct, click the same color on your mobile phone. Okay. So you see which problems do transformers solve? What do you think, everyone? Which problems do transformers solve? You have 15 seconds, all of you. The faster you answer, you will get more points. 10 seconds, 9 seconds, 8 seconds only. Everyone, 6 seconds, 5 seconds. Okay. Which problems do transformers solve? Fine. I can see 4 plus 3, 7, 9, 11 people answered. Out of that, only 2 people are right. Vanishing gradients plus parallel sequence processing is the problem which transformer basically solved. Vanishing gradient. I hope it will help you revise. What is gradient? Derivative. What is vanishing gradient? I hope so you are aware about. The most important reason why people don't go into the details of any architecture like this even because basics are not clear. That's what I have seen. Okay. Let's see next question. Okay, these are the people who answered fast. Someone joined as Maxi, Sharan sir, okay, Pratiksha madam, Aniruddha sir, and Professor More VP tried to answer, but fine. Next time also you will get chance. Next question. Embeddings are, I've told you, embeddings are, or you might be knowing about it already. Embeddings are what? So you have 15 seconds again, everyone. Answer fast. The faster you answer, more points you will get. Okay. Embeddings are what? Seven people only answered. 5 seconds, everyone. 4 seconds. 3 seconds. Okay. 1 second. Fine. Now this time most of you are right anyway. Like more people are right. Are numerical representations of input or output data. Yes, exactly right, all of you. Fine. So, okay, now most of you are able to answer. That is good. Sequence is somewhat changed. Maxi, Tushar, Sharon. Fine. Okay. Next. Third question, all of you. How do transformers encode the position of an input token if they do not learn it? I hope. Now, if you have listened me or if you are already aware about, or if you might have listened other participants as well earlier, everyone, definitely you must have come across this. Okay, 10 seconds you have only. 9 seconds. So mark your answer. Whatever the color you feel is right, mark that. 4 seconds only. 3 seconds. 2 seconds. 1 second. Fine. So they use non-linear functions, sine, cosine. This is how basically they tried. So sine cosine means what, everyone? Do you remember? I've told you the angle between the vector, the words. It is going to find out the vector. I've told you vector. That's why I shown you that particular diagram as well. Please try to relate those stuff, everyone. It's basic maths. Okay. The angle between the words if it is less, the angle between the words if it is less, everyone, it means what? It means those are most related words. Okay. Fine. Next thing, you try to answer even it's not about right or wrong, at least try. Fine. I can see people are responding here. Okay. This is the scoreboard. Next. Only 7 questions are there. How does the transformer solve the vanishing gradient problem? Now, how does it solve? How does transformer solve? Okay. I have used that particular word many times. So you have again 13 seconds, 12 seconds, everyone. You check it out. By training on smaller data set, today's overfitting by repeating the neural network. Check out the answer and then mark. 5 seconds, 4 seconds. 2, 1, fine. So two people are only right by applying residual connections. By applying residual connections. Okay, fine. Those who tried to answer, that is, I appreciate that definitely, everyone. Those who are trying. Oh, the sequence is totally changed now.
का नंबर है क्या आपको? ಹೌದು.
Sequence is totally changed. I think Sayeda Mahareen first, Maxi second, Tushar, Shital, Shafia. Fine. Okay. Next one. You see the next question now, everyone. Multi-head attention enables the transformer to multi-head attention encoder, 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 right? So I hope you remember that. You just check it out, everyone. 7 seconds, you have 5 seconds. Answer fast. Fine. Okay. So three people are right. Focus on different parts of the input when generating output. Okay. Now next question. Let's see the sequence first. Okay, again it is changed. That is good. People are answering. Fine. Now I think last but one question, all of you. Please check this. What are the names of the three vectors Q, K, V? Simplest question now. Q, K, V. Just now I've told you, right? Just some time before even. What is Q? What is K? You have 10 seconds, all of you. Answer it fast. This is what you are going to require in fine tuning as well. Okay. Fine. Yes. Query, key, and value. I think fine. People have, sent the options as well in the chat box. That is right. Now, most of you are right here. Okay. Those who answered faster, you can see the names like this. Okay. Now, I think last question, all of you. Seventh question. How does the attention layer score keys mathematically? So, this also I've told you, if you remember the last equation, attention score, one score is calculated, right? If you remember, I have shown you two words, transition and machines. We have 10 seconds, all of you. We have discussed this. I hope you are able to remember that. Based on that, only these questions are there. Fine. Most of you are able to answer it. I hope so. By computing the dot product of queries and keys, only two people are right. by computing the dot product of queries and values. No, queries and keys. Queries and keys, not values. Okay, keys even. That's a difference. Maybe some of you might have confused. Okay, because of that, or maybe time is very less, right? That's another reason. So you see again. Let's see who are these people who are able to answer it. Sayyeda Marin. Say third one. Okay. Second one, Aniruddha Kshir Sagar, I think. You have written short form maybe. Tushar, Mr. Tushar also, and other people are also there. Even you can check it out. Okay. But anyway, the motive was just to revise the things all of you, or by chance if someone was not aware about that kind of a stuff, the motive was just to get you know about that particular thing. Okay. So I will take it as at least that uh, made you understand about the things, even query key and value, right? So at the end of this session, even these are the things which we'll be learning. See this now. I think most of you have the idea, basic idea now. Okay. So after this session, participants will be able to explain why fine tuning is needed, differentiate between full fine tuning and something called as PEFT, parameter efficient fine tuning. So we are going to see everyone what is exactly PEFT, what are the types of PEFT, what is LoRa, what is QLoRa, and what are the different metrics to go and to evaluate all those models. And then you will be able to see everything. You will have to relate to the basic things, whatever we have discussed till now. That was the only reason why I just tried to revise it, okay, or brush up. So you will be able to differentiate between full file tuning and PEFT, right? Parameter efficient fine tuning. Apply LoRa based fine tuning on small models. Even LoRa is nothing but low rank adaptation. What exactly it is, if someone is not aware about, don't worry, it will be clear. Those who are already aware about it, fine, that is also fine, good. Then how to prepare datasets for LLM customization and evaluate LLM outputs. So this is where we are going to learn about the metrics even. This is where we are going to learn about the metrics. Okay. How to evaluate the LLM models. Again, every metric has advantage, limitation, and so on. And then everyone understand the deployment options and optimization strategies. So these are all the things everyone which will be understanding. Obviously, if you will be there till late. Next thing. Now you see all of you. LLM customization, the bigger picture. I just want to give you an idea about the bigger picture. So there are ways to customize the LLMs. What are the different ways? So see everyone, it is not only fine tuning. Fine tuning is something which we are discussing because that is the topic for today's discussion. But to customize LLM everyone, it is not like that there is only fine tuning which is possible. This is the focus of this FDP or the session. Let's say this session at least. Okay. But is it the only way to go and to customize something like LLM? No, for sure not. Then what are the other ways even? Prompt engineering. I think prompt engineering is a word which everyone must have heard. Definitely. And we are actually using prompts even. RAG also you must have used even. Even you might have worked on some projects as well. Just a simple example, let's say. What is RAG? RAG is like you just go, you just try to give some document to the model. The document will be basically read by that model, understood everything. It will store that data. And whenever you ask anything about that particular document, your model is going to give the answer. A RAG, retrieval augmented generation, is going to give you any answer about that particular document, book, PDF, whatever you say, right? So yes, this is also another way. I already have one a real-time application ready with me for RAG as well, even. But again, if we have time, then only we'll go with that one. Otherwise, not. Now, everyone, next thing is fine tuning. As I've told you, fine tuning is another way to go and to customize the LLM, large language models. That's the reason why we discussed about large language models, why it is called as large and why it is called as language model. Our discussion basically started with that one only. Okay. So this is the focus area going to be, and then fine tuning modifies model behavior by updating model parameters. Definitely, fine tuning is going to model the modify the model behavior definitely. But then why it is so? Why it is required, even the basic reason in the first slide itself, if you remember, even because the models which are large like GPT, Mistral, and so on, Gemini. If you talk about all these models, even obviously going and doing full fine tuning on them is not possible practically, because there are a lot of limitations. Resource limitation is there, data limitation is there, time constraint is there, and so on. And that's why when this customization, LLM customization or fine tuning is something which is basically going to come into picture. Okay. Now you see, Aryan, if by chance someone is aware about RAG, I think maybe if RAG is already discussed in the previous session, you might be aware about it. Retrieval augmented generation. So you see, again, this is in short the differences between fine tuning and RAG. Model weights, in case of fine tuning, everyone, they'll be updated. Whenever I say model, obviously weights, I think you understand, right? Weights are always going to change. So they will be updated during fine tuning. RAG, they are frozen. They are not going to change. Cost, in case of fine tuning, it's high. It is one time only, but it is high. But in case of RAG, everyone, it is lower per query. But it is recurring. As and when you go, you try to access as many number of tokens as you want, even the cost is going to increase in case of retrieval augmented generation. Okay. The best use for fine tuning Aryan is styling and behavior. If you want to change the style of the model, behavior of the model Aryan, go with fine tuning. Otherwise, if you want to go on, if you want to have knowledge updates, you want to update your model, just go on adding the data, bombarding it with more and more information, even go with RAG. I give an example, right? Let's say if you give me a PDF or a book, I will try to pass it to the model, right? And then it will go and it will try to read it. It's like it is going to save all the data, and then you ask it any question, anything about that particular book or the PDF, the model is going to give the answer. That is RAG. That is RAG. Okay, retrieval augmented generation. Fine. So these are the differences between fine tuning and RAG. Now you see it in next one. What is fine tuning? So I think at least the idea of fine tuning you must have got even. So fine tuning is the process of what? Taking a pre-trained LLM and then training it further on specific task or the data. Now training it further on specific task, but with what even? With the data. With the data as per the requirement. Training it further on the task specific data. Now this data, whenever we say this data, everyone, it can be labeled. Most of the times it is going to be labeled data. And I think you understand labeled data, all of you, right? Label means output variable, or we call it as dependent variable, right? Explained variable, or response variable, we call it as output feature, we call it as, right? Or the label, one and the same thing. So in case of fine tuning, everyone, yes, the task specific data most of the time is going to be what? It is going to be labeled. Simple thing. You take the base model and you go and you try to train that base model on the organization specific data or the requirement specific data. And that data most of the times given is going to be labeled data. Okay. What is the goal? Align model behavior with specific domain or task. Okay. Maybe let's say, I can give any real-time example here, right? Um, let's say airlines. Let's say Lufthansa airline owner says that, okay, I want to go and I want to have uh, an information about specific flight from specific source to specific destination and specific type of the flight, right? As per his requirement, specific requirement only. So that can be the example. Or you see again, legal document summarization, academic question answering, company specific chatbot, the example which I was trying to give just now. Again. So these are the examples one can go, one can have it with the help of something like fine tuning, everyone. But why it is needed, all of you? Why something like fine tuning is needed, everyone? Because there are, see, fine tuning, why it is needed? Because task specific, if you want to go and if you want to do the things according to the specific task with the help of the LLM models, you can have fine tuning. But again, there is something called as full fine tuning, but again we have other techniques of fine tuning again where you don't have to do full fine tuning. So let's say, first of all, let's see what is full fine what is full fine tuning. It's like going and changing all the parameters of the existing model, right? Every weight will be changed and everything will be done. All the parameters will be taken into consideration, which requires very huge time. So what are the challenges of full fine tuning, everyone? It requires GPU memory, graphical processing unit, high training cost, definitely. Risk of overfitting is always going to be there. I hope everyone understands the meaning of the word overfitting. In machine learning also generally we come across this, right? It means like the model might give you very good accuracy at the time of training, but at the time of testing in real time, it might give very bad accuracy. In very layman way, that's what overfitting is. and difficult for academic environments. Definitely everyone going and doing full fine tuning for people like us is not possible because we don't have that much of memory. We don't have that much of resources. And that's why everyone there is a solution that is called as PEFT. And this is the topic, right, which we'll be going and exploring. You see, PEFT, this is the first technique. Full fine tuning. I hope you understand. Going and changing everything, which requires huge memory. So what is the solution then? Parameter efficient fine tuning. We call it as PEFT. Parameter efficient fine tuning. Why parameter efficient fine tuning came into picture even? Because these are the limitations of full fine tuning. That's why. So whatever I am discussing, whatever I am saying, full fine tuning, what are the meaning of this? I hope you people are able to understand. But if someone wants to go add in between something as per your understanding, definitely you can let us know. Okay, now you see again parameter efficient fine tuning. So what exactly happens in this? We'll try to see the concept first and then we'll go to the implementation of this with a very simple example. Okay. So you see everyone, parameter efficient fine tuning, as I've told you why it is required, because it allows us to make use of a memory which is not uh, which is even very less memory is there, or I can say sufficient memory is there. It's not like that we are going to require a very high configuration like GPU, even if it is not there. But yes, with some limited resources as well, we can go and we can do the fine tuning of the model, everyone, in case of something called as parameter efficient fine tuning. It is one of the techniques of fine tuning, everyone, which is called as parameter efficient fine tuning. What happens here, even? What happens here? Only a small subset of model parameters are actually used. Small, see, whenever I say model parameters, I think you understand. Model parameters, model arguments. That's why I've told you, right? Like someone has answered it correct at the start that 175 billion parameters are used in case of GPT 3.5. So you just think about it, even if the number of parameters are in billions and trillions, it's really practically not possible to go and to do the full fine tuning. That is why there is a need of some techniques, and one of them, everyone, is nothing but what? Parameter efficient fine tuning. The name itself tells you what exactly it is. Here in this case, even we are not going to take all the parameters. Now, which parameters to be taken into consideration, even? For that, obviously, one should have an understanding of that domain of the problem statement, and then you can go and you can decide. So, AI engineers and architects also, maybe they can go and they can basically do it. Okay. Now you see that is the first need, parameter efficient fine tuning. Secondary one is why it is needed. We have seen that. Now base model remains frozen. Base model remains frozen means even we are not going to make any changes in the parameters of the base model. No change. It is frozen, almost frozen. So that is why parameter efficient fine tuning, everyone, is efficient in terms of memory, in terms of compute, and in terms of time. If it is efficient in terms of memory, everyone, that means with some limited resources as well, one can go and one can do parameter tuning or tuning, fine tuning of the model. If compute is required less, even, that means obviously the cost is reduced. Definitely. Time is always very, very important, right? Time is always very, very important, right? Fine. Now, next thing, everyone. I hope you got my point. Okay. Now, you see, talking about parameter efficient fine tuning further. So still if someone is not able to understand, have a look at this particular slide even. You will be able to understand at least what exactly it is. Right? It's a set of techniques that adopts large language models by training only small subset of parameters while keeping the base model frozen. No changes in the base model. Goal is what? Customize LLM behavior without full retraining. Right? It's like what, even? It's like let's say I will go and I will try to teach you about something, but not from the scratch. Because if you are already aware about it, then why? Why to waste the time? Energy will be wasted, time will be wasted, resources will be wasted, and so on, right? Something like that. But obviously, in this case, CPU, memory, right? And obviously, a lot of other things will be at the stake. That's why again, this PEFT, parameter efficient fine tuning, is going to play a very, very important role. Now, you see, why PEFT is needed? That is what I was trying to tell you. You just check it out here because there are some problems with the full fine tuning. Those are listed here. Whatever we have discussed. Have a look at it. We'll go to the next one. Requires huge CPU memory, high computational cost, risk of catastrophic forgetting. So I hope so you people understand this. This one as well. This is simple. Any idea what is the meaning of catastrophic forgetting? Those who are listening me, those are still there listening me or able to listen me. Risk of catastrophic forgetting. What is the meaning of catastrophic, by the way? Any idea? Because again, it is important. I told you. I already told you about full fine tuning requires huge GPU memory. It requires high computational time, high computational cost, and again, it's not feasible in academic or like this kind of environments, faculty development programs. This also you understand. One, two, three. You understand. Can anyone tell me what is this catastrophic forgetting? Anyone? Sudden destroy? No, not destroy exactly, Antosh sir. Fatal. No, no. Forgetting the features. Yes, forgetting the features. But how? But how? See everyone. Very simple. That is right. I think. Yeah. Say either Meherin. Yes, that is right. That is right. Something like this. See, let's say everyone, this person is there. Okay. Now, to this person, you have taught machine learning. You have taught, let's say, Python as well, right? And you have taught something like deep learning as well. Fine. This is what you taught to this person. Now, everyone, what has happened? You thought that okay, this person is really good. He's learning. He's eager to learn. He's always going and learning the things, right? Now you see, that's why what you did is this person or the student, whatever you want to say. Okay. Now you taught him something like some other language. Also you taught. You taught him something like machine learning operations as well. You taught him like cloud computing as well. Okay. You also taught him something like generative AI and a lot of other stuff. Everyone you went on teaching him. You taught him LLM. You taught him something like PEFI, right? Parameter efficient fine tuning, PEFT, and so on. So after some time, what will happen is he is going to forget these things. That is catastrophic forgetting. As simple as that. I hope it's clear, right? Yes, overwriting you can say. But you got my point. Everyone, others also, that let's say that person is going to forget this, right? In real time, every time it is not going to happen, but I'm just trying to tell you a simple example so that it will make sense. That is catastrophic forgetting. That means you are trying to train your model. You are trying to just fine tune your model even with something extra. But earlier thing is, yes, it is getting overwritten, right? So that's why these are the problems even with full fine tuning. And that's why PFT, parameter efficient fine tuning, solves this with limited hardware availability, cost constraints, and faster experimentation. Okay. Now, core idea behind PFT, everyone. What is the core idea behind that? Start with pre-trained LLM. See, everyone, this is a flow. This is a flow now. Start with a pre-trained LLM. It can be any LLM. Freeze all the original model weights. Add small trainable components even, and train only these components. Only those components, not the earlier which are freezed frozen, right? And then you will see again 0.1% to 5% parameters updated. Only 0.1 to 5% parameters updated instead of 100% parameters. And that's what it is going to save the time, everyone. Right? This is the core idea behind PEFT. Next, you see now, everyone. PEFT versus full fine tuning. PFT versus full fine tuning. So have a look at it. I think you are also able to understand this. Trainable parameters in full fine tuning, all in PFT, very few parameters will be changed. GPU requirement, full fine tuning, very high. In PFT, low. Training cost, expensive, affordable. Academic feasibility is no in case of full fine tuning. In case of PFT, yes. And in model reuse, very difficult in case of full fine tuning. PFT, yes. Okay. Now, where PFT fits in customization, even where it fits in customization, so you see in LLM customization approaches where it fits prompt engineering, RAG, fine tuning, right? And PFT basically it modifies model behavior, not just the input. This is something like this we already discussed anyway, right? Now, these are the common methods even when we talk about parameter efficient fine tuning. Which are those methods, all of you? LoRa, QLoRa, prefix tuning, prompt tuning, adapter layers, right? And LoRa is something which is basically preferred. That's why many times people might have heard about it. Those who might not be aware about something like this, right? Right? What about the narrow data sets? Don't use it. Don't use it. If the data set is very, very small, then what is the purpose of using it, Dr. Prashant? I hope you are getting my point. Then it is not going to make any sense. Going and using for something which is having very narrow number of parameters, even if you talk about very less. So small models, no need to use that. I think you are getting my point, or I am able to answer your question, right? Whatever you are asking. So in that case, don't use it. It's basically for what we are talking about the large language model. That's why we started discussion with large language models only, right? And you see again low rank adaptation. It's most popular, and on top of that only we have something like QLoRa as well, right? I hope others are also able to get my point, right? Fine in the chat box. Fine. Okay. So quantized low rank adaptation even. Prefix tuning, prompt tuning is also there. Adapter layers are also there. But this is something everyone which is preferred. Fine. Now LoRa, let's try to talk about this one even. Okay. And then we'll see a simple hands-on example. Okay. With till now whatever we have discussed about this fine tuning, let's go with a simple example. See, instead of updating full weight matrix, now see, this is the reason why I just tried to take you through something called as query key and value. So do you remember W vector was there? WQ, WV, WK. So instead of updating the full matrix, that is original weight W, in that W matrix, what was there? I told you it was like random values, like weights. So only learn a small update, right? This is basically change. Let's say del W. Okay. So approximation will be what even del W is approximately equal to A cross B, low rank matrices. I hope everyone understands what is the meaning of rank in a matrix. What is the meaning of rank? Basic maths we learn in school days. I think everyone is aware about it. So only A and B will be trained anyway, not the original matrix. Okay, that is what is the basic idea behind low rank adaptation. Why the name low rank? Because we are going to use low rank matrices. Now if someone wants to go into the details of this, those files are also there. I have a separate document, and there I actually explain each and everything with the help of formula, mathematics and code as well. But it takes some time, you know, okay, understand. That's why I'm just trying to give you the idea about the concept here. In the implementation, definitely we'll go to the Google Colab and I'll show you a simple code there. Okay. But yes, this is low rank adaptation concept. Okay. LoRa. Now LoRa, what actually gets trained here in this case? So base LLM parameters, they are frozen. No need to change. LoRa adapter matrices, they are trainable. So there'll be another matrix, right? LoRa adapter matrix, we call it as, and it is basically having trainable parameters. And typically they are added to attention layer. So what is attention layer? That we have already seen, right? And query key and value projections. Those are going to project to query key and value. And what is that query vector, key vector, value vector? That is the reason everyone why I actually tried to brush up that particular concept as well. Okay, fine. Why LoRa basically works well even? Because it brings massive reduction in trainable parameters, right? Right? You can use search definitely because Prashant sir, whatever you are asking, definitely you can use LLMs anywhere, anywhere. You need to figure it out, right? What exactly your problem statement is. You go, you check out the LLM models which can solve your problems, because you see, I've shown you, right? There are more than 20 lakhs models available as per the task. So definitely it's possible, because right now you talk about any domain, right? It's there. Generative AI is there. So massive reduction in trainable parameters. That's the first reason given. Faster training time, easy to remove or swap adapters, multiple tasks, multiple adapters are there, and one base model, many subject specific adapters possible. Okay. Coming to something called as QLoRa, quantized LoRa, everyone. Quantized LoRa. So what QLoRa basically adds? It makes use of base model loaded with 4-bit precision. I hope you understand precision level even. Precision level. If you talk about the models, even the precision level is very, very bigger. Here it basically loads the base model in 4-bit precision. That itself is going to make it quantized. So LoRa adapters trained on top right? Q LoRa is basically, that's why I've told you on top of this LoRa is there. What are the benefits even? Fine tune large models on limited GPU, lower memory footprint. Why memory footprint? Because the bit precision is lower. That's why. And yes, it is used when hardware is extremely constrained. Then whenever there are limitations in the hardware, even we go with Q LoRa. But what is preferred? LoRa. Okay. Low rank adaptation and other parameter efficient fine tuning techniques. They are like what even? Prompt engineering, learning soft prompts. Whenever we say prompt engineering, everyone, right? Again, there are other things which are going to come into picture whenever we talk about prompt engineering, right? Models are going to come into picture even. There are learners, zero shot learners, few shot learners. I hope you must have come across those kind of stuff as well in the previous sessions, right? And when you talk about other techniques, model weights, unchanged prefix tuning, train prefix tokens per layer, adapter layer, small neural network added between transformer blocks. This is also other technique everyone which can be used for fine tuning. And LoRa remains the industry default, even though all these things are there even. But if you ask me which one is mostly used, so this one. Obviously, why? I told you if someone wants to go into dig it into something like details of LoRa, definitely you can. I'll show the document as well if you get time. If we get time, I'll show each and everything about that one as well. But before that, we'll just try to execute a simple code so that the things will start uh, uh, making it easier, let's say, right? You will start getting the things basically, and maybe hope you will be able to understand the concepts when you will actually explore the things, right? In academic context, even as most of uh, the participants maybe are from, let's say, academic background. So parameter efficient fine tuning enables PDF FDP friendly demos. That means this kind of sessions. That's why I intentionally added that particular example. Student mini projects definitely can be possible even because there is no limitation. There is no constraint of memory sometimes, or if you have a constraint, then maybe you can go with parameter efficient fine tuning. Research experimentation can be done, and low cost institutional labs can be established with the help of something like this. Generally, in many of the colleges, many universities, colleges, they want to go and they want to develop the labs, right? So everyone see low cost institutional labs possible because there's a limitation. Everyone cannot go with the GPU and all, right? And this is the workflow, everyone, which we are going to follow now. You see this. If you talk about parameter efficient fine tuning, so load the pre-trained model, freeze the base parameters, attach the PFT adapters, and then train on domain dataset, show adapters, and then deploy the model. Okay. So let's try to see a simple example even for the PEFT demo, right? With the help of Python only, right? And these are the tools or the platforms everyone which I'll be using. Now if someone wants to go and someone wants to follow me, you can, those who are listening me. Okay. Python definitely will require Hugging Face transformers, Hugging Face platform. So Hugging Face transformers is nothing but whatever. Now you are aware about transformer architecture, you people are aware about transformer architecture, right? So to make use of all the models which are basically on Hugging Face platform, they are actually using transformer architecture only, right? So we will require a library with the name transformer. So that's why they call it as Hugging Face transformers. And PEFT library, because we are going to make use of parameter efficient fine tuning again. Data sets, we will create it because we don't have much time. So we don't have much time to go and to work on large data sets as well. We'll create our simple data sets, our own data sets. Okay. And then everyone, yes, Google Colab or even local GPU is also fine, but local GPU is not there. So I'll be using Google Colab. Okay. I hope so. Till this point, everyone is able to understand like at least whatever is going on here. Okay. Fine. So let me go from here, everyone. We are on page number 22, right? So see now, everyone, I'll go and I'll just try to show you the code with the help of which we are going to implement the first technique, and that is nothing but parameter efficient fine tuning. So I created one file here. Again, the code is already available on the internet as well. If you just go and check it out from your end as well, even you will be able to find it out. But this is the best way. See, this is the best way if someone really interested and really thinking about learning something like this. Definitely it takes time. Definitely it will take some efforts. But once you are clear, everyone, then it will not take much time later on. Things are really interesting if you go and you do proper hands-on and all that stuff. Now see everyone, what you do is you just go open Google Colab. Let's say I'll open a new file here. Okay. Google Colab, I think everyone is able to access. Obviously, if someone is joined from mobile phone, then it is not possible. It is also possible, but then copying and pasting will be very difficult for you. Even though I'll be sharing the code in the chat box, but if for some of you, if it is possible, you also go and check it out. Definitely, we are going to get the errors even because we are not using all the parameters, so it will show the errors. But anyway, we'll use the model which is available on the Google Colab itself, and we'll ask that model itself to solve our problems, so that at least you can have a look at the code which I am showing you, so that you will be able to understand this flow everyone. Okay, this flow. So this same flow I am trying to tell you. Okay. So fine, I have this first thing everyone is change the runtime. Change runtime type to T4 GPU. Okay, because everyone is using free. So we'll go with this. This is the first thing which you need to do, all of you. Okay, this is the first thing which you need to do. I'll connect to T4 GPU. Right? I hope so you are able to understand. Simple thing, everyone must be aware about Google Colab. So I'm using the same everyone, nothing different. Now see everyone, you might be knowing that if you really want to go and check out, what type of a GPU you are actually making use of, everyone, even again anyway, uh, NVIDIA GPU you are using, right? So if you just want to go and check it out, are you really connected to that? You can simply go and check this command review. Just check it out. I sent it to you in the chat box. Explanation mark is added. I think you know why do we use explanation mark. Whenever we run any terminal command in a notebook like Google Colab or Jupyter Notebook or Jupyter Lab, even we start with this one. So this should tell me that, okay, fine. You see, I'm using Tesla T4. Okay, this is what I'm using. So I'm able to see this. This command is already sent to you in explanation mark NVIDIA dash SML. So it's telling me that, okay, fine. I'm just confirming, okay, I'm connected to the GPU only. Fine. So let's try to add some more cells. And now everyone, now I will go and I will try to do the parameter efficient fine tuning for this particular file. Okay, this is my VS Code. It's not compulsory that you should also open it in VS Code. You can open this file anywhere. So you can see what I've done here is actually when I generally discuss about something called as transformer driven transformer architecture. At that time, I generally talk about transformers, data sets, accelerate, evaluate, torch, and sentence space one by one. But in this case, as we are directly talking about something called as fine tuning, so I'll be expecting that maybe you might have come across these libraries earlier. At least transformer, datasets, accelerate, evaluate, torch, and sentence space. PFT is what something my topic is, but maybe you might have come across these libraries. Okay. Transformer, because we are going to use models maybe from Hugging Face. Datasets, because we are going to create some datasets. PFT, because parameter efficient fine tuning is what we are going to use. Accelerate everyone is what we are going to update certain packages, evaluate for metrics, torch, PyTorch we are going to use, sentence piece we are doing to do tokenization. Okay, that's why. So that's the reason. But generally, as I've told you, I go and I try to talk about all this stuff one by one because I assume that it's not compulsory that everyone should know this. But I have seen the topics as well in the previous sessions. According to that, definitely 3 year session, if you talk about, definitely this must have, at least you must have come across. Even if not, no problem. I've told you what are the use. You go, you try to execute this. If not today, maybe once you get this file, you try to execute the same. Even I think the session is also being recorded. Okay. So you check it out. Even I've sent it to you there. Those who are still following, maybe I'll simply try to paste that same thing here. If it is not installed in my case, I will ask the model itself. Okay. So you see everyone, it is downloading pip install transformers, datasets, PFT, everything. So you see it has downloaded that. Okay. It has downloaded that. But anyway, before the session itself, I already tried it because many times we get the errors and all that stuff. If someone is getting the error, just let know. Otherwise, if you are also using Google Colab, even Google Colab itself tells you how can I help you. So see, you see, Gemini is there. Gemini 2.5 Flash is there. So it's like co-pilot. It is going to help you everyone. Don't worry. Okay. So go there. First thing is what? Environment setup. We have set up the environment. Now everyone see the libraries. Okay. Torch, because we are going to use tensors. I hope you understand tensors even. In neural network, tensors are going to come into picture even. Right. So what you do, all of you, I'll send this code to you in the chat box. Those who are following me, you do this line by line. You see, like this. Don't import everything at once. One by one you go, because otherwise it takes some time. It will execute, but it will take some time. Import torch, because I'm going to use PyTorch. PyTorch library or framework, everyone you must be knowing about, right? PyTorch is developed by Facebook, and something like TensorFlow, right? So is developed by this one, Google. Okay. So Keras, I hope you are aware about that. So you see in PyTorch is imported here, Torch or PyTorch. And now you see again what am I doing is from transformer library, I am doing auto tokenizer. Auto tokenizer, what it is going to do again is, because these LLM models, they use auto tokenizer for tokenization, and auto model for causal LM, large language models. Then for training arguments, everyone will be using this method, and for training the model itself, everyone will be using trainer. Okay. So you will see the use of all this stuff one by one. Let it run. Till that point, I will paste the next, and I'll be running the next as well. Next line. So you see, from transformers, we are simply importing it here, nothing. We have installed all the necessary libraries now, and we are simply importing them one by one. Okay. So you see, all of you, if you see, those who are following me, as I've told you, you run it line by line the way I am running it. Because why? The reason is, everyone, in short, what it is going to do is, in short, it is just going to some, let's say, some websites, and it is going to fetch the required things. It's like loading, right? So it depends on the internet speed as well, and some other parameter, other things as well. That's why it might take some time in your case as well. If you run it at once, then it will take more time. You see, it is done. It is done in my case, 54 seconds it has taken, almost 1 minute. Fine, no problem. Let's run this from datasets, import dataset. So we have imported it anyway. And now everyone, you see, the actual library which we require for fine tuning, right? Parameter efficient fine tuning. So I'm just using, see, LoRa config and get PEFT model. So this is the thing which is going to do our task, the topic, right, of this particular discussion level, right? So I have imported that, and the last thing everyone is evaluate, because this is something which is going to help us to evaluate the model as well. Earlier, this particular library was with some different name, everyone, but fine. Now it is evaluate. Okay, fine. These things are already shared with you, all of you. Now I'm going to load the pre-trained model and tokenizer. So do you remember, everyone, when I showed you the flow, the entire flow, everyone, in that case, right, you need to load the pre-trained or the base model, exactly same thing. So do you see again which one we are using? Distill GPT, Distill Bird, Distill GPT, whatever you want, you can go, you can use that. Again, by chance, if someone is following me, you just go one line at a time. Okay, one line at a time, everyone, because when I ran it, I've seen that if I directly run it, it was taking some time. Maybe sometimes if you are getting error, we'll see that anyway. So you see, everyone, I'm just creating a variable with the name model underscore name. I'm giving the model name as distill GPT. So now if you copy this name onto Hugging Face ribbon, you will get all the details. Whatever the code which I'm going to show it to you now, all that code you will be able to see there. By chance, if someone is worried about, okay, how to go and how to remember this kind of code and all that stuff, you really don't have to, area. You see, I'll show you other lines. I'll paste it here, and you see, again, I'll copy this name. Maybe many of you might be aware about it, fine, but those who are not, for them, let's say, let's go here to this. Now you see, again, if I try to check out Hugging Face, see this, because I've seen people generally, when they see the code, they feel that, okay, is it like all coding? It's not. Okay, it's not actually. If I click on models, and if I search here, paste that name, and you see, again, I am getting Distill GP2. See, I'll click on this Distill GP2. So every detail about Distill GP2 I got. Distill GP2, short for Distill GP2, is an English language model pre-trained with supervision of smallest version of generative pre-trained transformer 2. Like GPT-2, Distill GPT-2 can be used to generate text and so on. So developed by Hugging Face, transformer-based language model. That's why we discuss about transformer architecture, English language, licensed under Apache 2.0. And you see here, if I scroll down even, all the code and everything also you'll be getting. Other than that, if you want to check out the data sets, adapters, 17 models, fine tunes, 949 models, you might be knowing it, right? If you might be knowing that, you also can even upload your model here on Hugging Face platform. Even people like us also can deploy their models. So you can see this everything they are basically given here. Okay, so by chance if someone is thinking, okay, am I supposed to write down all that code and everything? It's not like that, everyone. It's not like that. The code is something which is already there on this platforms. Okay, fine. So I have created the variable with the name distill gp2, and then everyone, you see, I am creating an object called as tokenizer, and that object I'm able to create everyone with the help of auto tokenizer. What is auto tokenizer, by the way? Auto tokenizer, everyone, is basically the method used by models, LLM models, the GPT models, we can say, for tokenization. And what is tokenization? I've told you already. So there are different techniques of tokenization as well, which you might have used in Python, or maybe in NLP, or in machine learning project, deep learning projects as well even. But GPT makes use of auto tokenizer, right? So from pre-trained model, which one? Model name is distill GPT. Fine. Next thing, everyone. So we created that object tokenizer, and from that object, everyone, do you see what am I doing? Tokenizer dot, do you see EOS? EOS is nothing but end of sentence underscore token. So whenever there is sentence end of the sentence, it is taking it as a one token. So I am just creating tokenizer dot pad underscore token. And then, everyone, model auto model for causal large language model from pre-trained model name. So language model is what we are using, everyone, because we are going to just pass some data, text data, and this model works on text data, we have seen now, right? So you see now, everyone, it has downloaded that particular model, and it is basically giving us some information. Okay. Now all those lanes are already shared with you. Okay. Now sample instruction. So this is our data set driven. Obviously, we cannot go we cannot go and we cannot use the entire data set or the bigger data sets, all of you. We cannot use them, right? So what we have done, even see, this data set is very simple, right? Our data is like what? Key value pair, dictionary, text, and list. Text is a key and list is a value. So inside that we have question. Question is what? What is machine learning? Answer: machine learning is a subset of AI. Question: define deep learning. Answer: deep learning use neural networks. Question: what is generative AI? Generative AI creates new content. Something like this, everyone, we have as a data. Okay. Again, I send this in the chat box as well. I'll go here. I'll try to just run it here. So you see, all of you, data is equal to this. Okay, data is equal to this, and the data set, if you want to go and if you want to see the information about the data set, you see features, text, and number of rows, basically 3. Number of rows are how many, everyone? Number of rows are 3, right? Now fine, I think till this point you people are also able to do, like those who are following. Next, everyone, is tokenization. So I've told you tokenization generally is what I've talk about it separately because there are a lot of ways to do it. Sentence tokenization, word tokenization. Here, what we are using, auto tokenizer used by GPT models, because we are going to work on fine tuning of the GPT-2. That's why. Okay. To define tokenize, we are defining a function even where we are using tokenizer object, which we already created with the help of auto tokenizer. If you are listening me, and then it is going to do what? Batch of text and padding and all that stuff we have used. Maybe for this, sometimes if it is going to give us the error, no problem at all. We'll solve it. Okay. So you see, everyone, we are defining that function, and then we are creating an object of that dataset.map. We are mapping it to what? Tokenize this function, we are mapping it to, see here, in dataset. Okay, so what is dataset? Just now I shown it to you, that dataset. So mapping is done. Mapping to our tokenize function, we have mapped it to our dataset. Tokenize function, even we have mapped it to our dataset. You see this, each and everything I'm just trying to send it to you as well. Okay. Now next thing, everyone, apply apply LoRa, right? Low rank low rank adaptation. Okay, low rank adaptation is what we have applied here, what we are trying to apply. Okay, now see, I'll share this, but again, what are these things? LoRa configuration parameters even. How are we able to use it? Because we have already imported the method related to this. So again, I'll just try to share this with you. Please check it out in your chat box as well, even check it out. I send it to you. Okay. And I'll also go run it in my case. So you see all of you, LoRa configuration parameters. If by chance someone wants to go and check out in the details of each and everything, you can. Here itself it has given. What are the different parameters? Even we have not used all of this. Okay, this is a method even. It's like a method. You know, pandas. Inside pandas, there are a lot of methods, right? Each method does specific task. Okay, each method does specific task. Exactly same thing, everyone. LoRa. LoRa config is basically a method. Inside this, we have a lot of parameters. Out of that, we are using some of them. We are not using all of them. But if someone wants to go and check this out, you go over the cursor. It's like a doc string. You see everything they have basically given here. You see, this is the configuration class to store the configuration of LoRa model. You see this? Everything they have given here. Everything they have given here. Okay, fine. Now we pass those parameters here. Okay, and you see trainable parameters are 147k, 147 comma 456, all parameters. This is the count, and they have basically given us some trainable percentage as well. Okay, fine. I shared this one with you already, everyone. And now training configuration. So training arguments. So what's going to happen here now? It is going to create a fine-tuned model. It is going to create a fine-tuned model with parameter efficient fine tuning, that is LoRa. It is going to create that particular model. Okay, fine. Now you see everyone, in this case, okay, I'll share with you. Okay, in this case, I'll share with you. Please check it out. Now you see everyone, here if I click on this folder, okay, here sample data is already there. So in my current folder, in my collab storage, Google Colab storage, you will be able to see there will be a folder with the name LLM fine tuned, and that is going to be our LLM fine tuned LLM basically. Here you will be able to see that. Okay, it means what? It means actually you'll be able to see certain files. The code is already there with you as well. Please check it out, all of you. I will try to do it in my case, and let me see whether I'll be able to see the folder or not. Okay, maybe when we'll go, so this is basically again arguments. We'll go and we'll try to run it, and then you'll be able to see the folder as well. Okay, you also check it out in your case, everyone. I'll go here, and now I will try to fine tune. So with the help of trainer, we'll go, I will try to fine tune, and then the training arguments, whatever we have used, everyone, I will go and I will try to use all that stuff. But how do you run it, everyone? See, I'll show it to you. How do you run it? So what exactly fine tuning is? That's what I'm trying to show you practically, so that there should not be any confusion kind of a thing here. Okay. So you see now, right now we are not able to see the folder. Now what you do is trainer.train. Before this, you simply run trainer is equal to create an object called as trainer with the help of method called as trainer. And then everyone, the actual training will start here. We are calling that method trainer.train. With the help of trainer, we are calling train, and this is something which will do our task. Yeah, this might take some time, right? Fine. If you are able to see error like this, please check it out. Don't worry, you will have to just go click on this. You have Gemini 2.5 Flash as well. That will also solve your problem video. Let's see. I'll ask it. Solve the above error. It's not compulsory, everyone. It is just because, see, everyone, it is just because sometimes what happens is there are updates in the parameters and all that stuff. Okay. So I'll press enter, and then I'm just asking Gemini 2.5 Flash to solve that error. It will suggest. It will give me some options. Do you want to accept and run all that stuff? We'll go and do it. It will go and it will make the changes accordingly. You see, accept and run. Okay. So see, it is running, everyone. And I think it has run successfully. Fine. Close this. You see again, it has run successfully, 100%. It is done. I'll add the new cell, trainer.train method. Okay, I was getting the error, and now you see it is fine. Okay, so it has done that Gemini Flash itself even has done everything. Okay, you can see it is running in my case. And now everyone, text generation we will try to do after fine tune. Model is fine tuned now. Okay, You please check it out, all of you. See this. Model is fine-tuned now. You go here, you see LLM fine-tuned. In my case, I'm able to get the folder here. Do you see everyone this one? Those who are still there, are you able to see this? Are you able to see this LLM fine-tuned even? This folder is created. Now, if I want to go and if I want to show it to you by expanding it even, you'll be able to see checkpoints, readme, and you see these checkpoints are there. And here you'll be able to see the trainer state even, this JSON file. You go, you try to explore these things even. You will understand exactly what happens when we talk about something called as parameter efficient fine tuning or LoRa or QLoRa and so on. Everyone, till this point, is it making sense, all of you? Because I'd be curious to know, at least those who are listening. I fully agree, you might be in your office, something like that, but are there any participants those still are able to understand, getting my point? Everyone? At least few of you, are you there? Because I'll be curious to know. Yeah, fine. Fine. Okay, thank you, everyone. So at least few participants are there anyway. Hope others will definitely go check out the things, explore it. Because see everyone, even though you might feel that okay, something like this you might not require and it is something time consuming and all that stuff. But let me tell you, whatever people talking about AI, use of AI in automation, use of AI in something like industries from the scratch, right? AI ML implementation in the industries, everyone is going with that. You will be able to make some sense here, even. And who knows, by chance, if you get an interest and then if you explore and then if you try to connect the dots, some opportunity might come in you, right? Fine. Anyway, so you see, I'll go here and now everyone see, I'm just giving it the question because we are already fine-tuned it. Same thing I sent it to you as well. Please check it out, all of you, right? So prompt question is what is artificial intelligence and answer. Now answer we are not giving it. Earlier what we did even, you see, earlier what we did is we have given what is the, see we have given the question here and the answer as well. But now what am I doing everyone? I am not giving the answer. Question, what is the artificial intelligence, right? So we are simply passing that particular prompt here, you can see, right? And then model.generate star means what? Many inputs, right? And maximum number of tokens you understand, like the how many number of tokens should be there in the output. And then we are simply printing it even. Okay, so if you want to go and check out this, maybe you will see. Okay, no problem. Again explain the error. So I'll just ask it again to solve that. You will see some output, not necessarily that it is right, but you will see it. Okay. Accept and run. Now fine, I think it is running everyone. Yes. Do you see everyone? We got some response. Do you see everyone? We ask what is artificial intelligence, right? So what is artificial intelligence? Answer, I think it is very interesting question. So we are getting reply. I think it is very interesting question. I think it is very, so we have limited it to 30 tokens, right? But do you understand everyone, after fine tuning, it is giving me some reply. Definitely. I said that it's not compulsorily right, but you see all of you, we are actually able to get something here. And let's say if I ask it something else, instead of what is artificial intelligence, I will ask it what is machine learning. So because that kind of a question also I think we have already given it, right? So you see what is machine learning? Machine learning is a new field of research that has been exploring the potential of machine learning in the field of something like this it has given. You see, I've told you because obviously the data was very, very less, right? You understand the limitations, right? So you see, and now everyone, let's say, suppose if I ask it some irrelevant question, something irrelevant, right? Let's say, let me see. If I ask it where Keystone School of Engineering, right? Something like this. You just modify it. Where is Keystone School of Engineering? Okay. Now I'll go, I'll ask it. So you see, Arian, something like this it has given you. After fine tuning, okay, obviously. So fine, yeah, I'm getting something like this here. So the Keystone School of Engineering is this something like this, right? Because it was not trained on something like this. And that model is also a very, very basic model, anyone. That's why. Okay. So I hope so. You are able to understand even how that EFT technique is applied, right? And how are we basically making use of LoRa? How are we basically making use of something called as LoRa? And now coming to the evaluation even. Evaluation can be done many different ways. Whatever you are able to see, perplexity is one of the ways. I will show you other things as well. But for time being, series, for time being, everyone, just check it out. Okay. If someone is still able to do it, perplexity is one of them. Even there's a model with the name perplexity as well, if you are aware about. Okay. So you see everyone, this is a metric. Okay. I'll talk about it. Perplexity. I'll talk about it. I'll give you an idea about this one as well, even. What should be the value of the perplexity? In what range? We'll talk about it. But for time being, understand that what exactly it is, even it is just a metric to check out how your model has basically performed. Okay. LLM model basically. So I'll talk about it, but let me show you the values of the perplexity metrics. You will be getting some loss, right? Later on we'll go and we'll try to interpret the meanings of those. In the PPT itself, I have already given that. Okay. Yes, I think, yeah. In between, someone was asking me about YouTube. So here also I have a lot of other things mentioned even. If you want to go check it out, if you are interested to go and to explore this kind of stuff, you can. Okay, check it out. You can go there and you can check it out even. Okay. Meanwhile, it is being training. You can check this. Okay. Here also you'll be able to find out a lot of other things related to all this stuff. And generally I upload it. Okay. Those who are interested, definitely they can go and they can check this. Fine. Am I still getting the error here? Let me see. Perplexity. Okay. Just a minute. Okay, fine. Accept and run is what we need to do here. Okay, still error. Close this. Module type metric. What is the mistake here? Okay, module cache file doesn't exist. Anyway, let's go with this again. For perplexity, everyone, what I did is I already have created a separate file. Okay. For perplexity, I have already created a separate file, which again I'll be sharing with you next. Like I'll be showing it to anyone. What's happening? Sometimes it takes time. But anyway, everyone, our model is pre-trained, fine-tuned with the help of parameter efficient fine-tuning, and there we have used something like LoRa. Okay. So I'll show you next file. Before that, I'll just try to complete the remaining things in the PPT. And then for QLoRa and other techniques as well, I will show you the code, same code. Maybe I think I'll have to check it out even what's happening. But anyway, we'll get the solution. That's not a problem. Okay, fine. So you see this perplexity value, I will talk about it, what exactly happens here. So it will give you an idea about how your model has performed. And finally, if you want to go and save the model area, and you can save it like this. Okay. And yes, PFT enables fine tuning on limited hardware. LoRa updates only small trainable parameters, right? And yes, it is suitable for labs, demos, student projects, and all that stuff, everyone. Okay. See, what I was telling everyone is if someone wants to go and check out what exactly is perplexity, right? So you see, this document also is there even when I try to create all these PPTs, the resources and everything, I'll just share here. See, Perplexity measures how well a language model predicts the next word in a sequence. Low perplexity means what? Better language model. So it is widely used for language modeling, pre-training, fine-tuning LLMs. That's what we try to do here. And comparing base versus adapted models. Adapted means fine-tuning, let's say. See again, intuition is also given. Perplexity answers how confused is the model when predicting the next token, next word. Low perplexity means model is confident. High perplexity means model is uncertain, confused. Okay. Usual values. Perplexity equal to 10. Model chooses among 10 likely words. And if it is 100, model is very confused. Mathematical definition, if you want to check it out, even you see perplexity equal to e to the power loss. And this is the equation. If you want to go into the details, you can check it out. But see, less than 20 value means very strong language model. 20 to 50 means good. 50 to 100 means weak. Greater than 100 means very poor. Okay, and it depends on data set and vocabulary size and tokenizer. Okay, other methods also are there everywhere, which we'll discuss in PPT and in implementation as well if we get time. But perplexity, yes, I've told you. And by chance, if someone still is not able to understand through PPT, you can go through this file as well. Okay, so now I'll continue the PPT, everyone. Let's try to talk about the remaining uh, topics of discussion here. Okay, so fine. 22 and so on, PFT. Okay, fine. So these are the things which we are discussed till now. You can check it. Okay. LoRa, QLoRa, PFT techniques, and hands-on. Right. This was the last. Now next one. Okay. This is what I was trying to show you. Hands-on PFT conceptual code flow. Whatever I shown you is like from the start till the end. Data. We actually imported a transformer library and all that stuff. And this is basically the conceptual code flow. Only LoRa parameters are basically trained here. Something like this, everyone, just know I have shown it to you. If you are really at least listening me. How to evaluate, you can see this. Whatever I was trying to show you was only perplexity. But is the perplexity only matrix to go and to evaluate the model? Absolutely not. There are BLEU. We'll talk about it. What exactly is BLEU? Right? It is bilingual evaluation under study. Okay. I'll talk about it. Okay. I'll talk about it. Okay. Bilingual BRL. Okay, fine. I hope you know the spelling and all. Evaluation under study. Okay, this is something which we'll talk about, and RUG also we'll talk about. Even ROUGE RUG. This is basically recall oriented. Recall, recall in case of confusion matrix, in case of classification models, even you must have come across something called as recall. So recall oriented understanding for gisting evaluation. Recall oriented understanding for gisting evaluation. If someone has not come across this, see, I'll just write on the full form at least. Recall oriented understanding. So what is the meaning of that? We'll see this. Recall oriented understanding for gisting evaluation. GISTING evaluation. So if someone asks you how to evaluate the LLM model, fine-tuned model, let's say here in this case, behavioral improvement you can check, domain relevance with the help of domain expertise, fluency and consistency, and the metrics everyone. If you ask machine, BLEU bilingual evaluation understanding understudy, RUG recall oriented understanding for gisting evaluation, and perplexity. What is perplexity? We have already seen that. Okay. Now let's see. Moving to the next. PEFT deployment perspective. This deployment, obviously showing deployment here is not possible even, but you see, you can merge adapters with base models, load adapters dynamically, and you can actually serve via some application programming interfaces. Like fast API is there. A lot of other APIs also are available even. Okay. And yes, PFT reduces inference cost as well. I hope at least some basic idea you must have got. That's why you are able to understand this. PFT, yes, it makes LLM fine-tuning practical. LoRa is the most adapted PFT technique, ideal for academia, limited compute, enables rapid, cost-effective customization. And everyone see, for example, simple example is PEFT allows you parameter efficient fine-tuning allows us to teach LLM fine tuning in classrooms without data center. As simple as that. In very simple words, even this is what I can tell you. Because of parameter efficient fine tuning, it is possible to go and to talk about something called as LLM fine tuning in classrooms without data centers. Possible. Okay. Now you see again, next thing. LoRa, low rank adaptation. I have already shown you the implementation. This slide is, I think this particular slide is repeated. You can check it out even. Okay. Yeah, this also we have seen all of you. Now, talking about quantized, I told you, right? 4-bit quantization it makes use of, and it is basically on top of LoRa. Enables fine tuning of larger models on limited hardware, and academic research, cost sensitive environments can be the use cases. Other techniques, yeah, we have gone through this prompt tuning, even prefix tuning adapters, but LoRa is the best. Something like this is already mentioned earlier as well. And now you see it in dataset preparation and why it matters. Why dataset preparation is actually most important, everyone. One of the main reasons is hallucinations and bias. Hallucination is nothing but what? Definitely false output. I think everyone must have come across this particular word, right? Hallucination, incorrect output. So yes, model quality depends heavily on the data quality. And poor data is going to lead to hallucinations, bias, incorrect outputs, incorrect next word, and so on. Okay, that's why that's why everyone dataset preparation is very important. Types of fine tuning, everyone. Instruction based question answer dataset, like we tried to do everyone just now. Conversational datasets, domain adaptation text is also possible. So it depends. It depends. If someone has tried all of these techniques, they might be aware about the scenarios. As per the need, you can go, you can use that. Just now we are using something like question answer dataset. Dataset format, do you remember even exactly same thing I also have used? Instruction was given. What is machine learning? Answer was given, right? So input output. Machine learning is a subset of, yeah, something like this. And now everyone data cleaning steps. That is what I was trying to show you in one of the files even, right? Tokenization and all those things. When I try to show it to you, data pre-processing and data cleaning steps are also there in one of the files. But obviously the best way is what? To do it hands-on. So remove duplicate, normalize text, standardize it, filter long short samples, remove HTML tags, validate length of the token and all that stuff. Many times you might have done it. Annotation best practices even. Clear input output alignment, obviously. Consistent instructions even. I hope you understand the meaning of this. There should be consistency in the instructions. Avoid ambiguous labels. Label is output variable, dependent variable, target, response. And human review for quality. Always there should be an involvement, right? If you talk about the domain expertise, human review should be there. And yes, everyone, hands-on architecture. So fine tuning pipeline. So we have used one method actually for fine tuning with the help of LoRa. Okay. Load treated model, load tokenized data set, apply LoRa. And same thing everyone, actually, whatever we did, exactly the same flow we tried to follow. So if someone wants to go check it out, this is the steps. These are the steps really which we followed. Okay, and yes, hands-on model. So whatever I've shown you in was like what? Distill GPT-2. You can use GPT-2 or you can use Llama conceptual model as well. Or even everyone, I already have other models as well, right? Uh, but again, time, okay, time is required. Later on, you can definitely go and try. Definitely. Why small models? Obviously, why small models? Because it should take time, less time, maybe, and we don't have GPU always available. Even faster training is what we need, and low compute requirements. Obviously, everyone cannot afford something like GPU. That's why. Okay. And yes, these I shown you already, everyone, but you can try out with for some other examples as well. Tokenization also I have planned hands-on demo, but fine. You can go, you can check it out with the files which I'll be giving it to you, right? Convert text into tokens. Token is a word. Handle padding and truncation, important for memory efficiency, model stability, right? To avoid the problems. And define LoRa parameters. So there are different parameters even whenever we go, whenever we talk about all these kind of techniques, right? Low low rank adaptation. Okay, low rank adaptation. Whenever I use that particular technique, everyone, if you just go over the cursor there in, let's say, Colab notebook, you will see all the details and details about rank. Rank is going to rank of a matrix. I hope you understand, right? Rank, right? If you have a 4 by 4 matrix, 2 by 2 matrix, and so on. And then other parameters are also there. Alpha is like a constant value and target layers. So it is going to freeze base model weights. No change in the base model weights. Okay. And this one you can see everyone, the configuration basic, which we also tried to do everyone earlier. So you can see batch size we can mention earlier. Epochs, I hope you understand how many number of times you are going to pass the data. Learning rate, how much faster or slower you want your model to learn, right? It's a constant value, generally between 0.00001, 0.00001 to 10. Ideal value of learning rate is what? 0.01, 0.02, or 0.05 is most commonly used. Okay, this one. Generally 0.01, very, very lower value we use, right? Or 0.05, something like this. Generally in machine learning also we come across this. Fine. Now everyone, yes, trainer APIs, I've told you a lot of APIs available. Monitor the loss with the help of the metrics. Okay. And yes, compare output before fine tuning and after fine tuning. Maybe if someone is trying to tune the model, check the output before tuning and after tuning. Okay. So that will also understand you how your model is basically performed. And why model evaluation, by the way, everyone? Why are we talking about something like RUG score, right? Something like perplexity score and other metrics evaluation? Because they help us to measure, compare, and avoid. So they help us to measure improvement objectively. They help us to compare multiple models. And yes, they help us to avoid the subjective bias, biasing of the model, hallucination in the model, incorrect outputs, and all that stuff. Okay. And now talking about something called as bilingual evaluation under study. Bilingual evaluation under study. So it basically measures n-gram overlap. Now n-gram is nothing but what, even it's basically a technique if you are aware about. It can be 1 gram, 2 gram, 3 gram, and so on. It means what? 1 gram means what, even? It will simply check out one word matching or not. If you have 2 gram, it will check two words are matching or not. Right? So see, I'll show you the example here just to make you understand. Evaluation matrix, bilingual evaluation under study. That is basically the full form of this one even. The value is between 0 to 1. The value is between what? 0 to 1. So you see now how basically it works. Okay. Typically, LLM overflow, base LLM model we are using GPU2, Llama, Mistral. Fine tuning using PFT, how it is done that we have seen. LoRa adapters trained and generate the text, and then evaluate using bilingual evaluation under study. For example, the base GPT for that BLEU value was 18, and LoRa fine tune for that the BLEU value is 32. It means what? Clear improvement with the minimal training cost. Higher the value, better the model is. Higher the value, better the model is. At least that you remember. If someone wants to go into the details of bilingual evaluation under study, definitely, again, the word file is there. Right? If you want to go and have a look at that one as well, yeah, it is there. You see, here also, I already documented everything for that particular method. Each and every metric, whatever it is basically shown in the PPT of you, it is there. See, bilingual evaluation under study. What is it? It's an automatic evaluation metric used to measure the quality of text generated by language models, especially in machine learning translation, text generation, LLM fine tuning evaluation. If someone asks me, what is the basic purpose of something like this? So these are the examples. What it measures, by the way, n-gram overlap between model generated output and the reference text. The original text and the generated text after fine tuning. Still, if you are not able to understand, see the example. Those who are there. Higher overlap is better generation quality. It means what? See here. Precision of n gram, 1 gram, 2 gram. Okay. Brevity penalty, BP, penalizes very short outputs. 0 to 1 often reproduced as 0 to 100. Higher is better. What is the meaning of this one? See, let's say reference data was the cat is on the mat. The original data was what? The cat is on the mat. And the prediction is what? The cat is on mat. So you see, this is basically good overlap. Only this is missing. So this is BLEU is very, very high value. That means it's a good overlap. It is used when anyone evaluating fine-tune LLMs. Just going and fine-tuning LLMs is not sufficient even. You need to evaluate those. So how to evaluate? First method we have already seen, right? Perplexity, I just tried to give an introduction about that, everyone. And then BLEU also we have here, right? Comparing base versus fine-tuned models, reporting results in research and FDP sessions, fine, it's fine, okay? And this is also there, but yes, I think you are able to understand my point even whatever I have discussed here. Okay. Next. Evaluation metric. Now talking about RUG. So RUG is basically recall oriented. I hope you understand recall, right? Accuracy, precision, recall, F1 score in confusion matrix. Generally, we come across that. So again, RUG is also of different types here. RUG 1, RUG 2, RUG L. So it is popular in summarization tasks. Okay, it is popular in summarization tasks. Let me just show you in 5 minutes what exactly it is. See this RUG. It basically stands for recall oriented understudy for gisting evaluation. It is recall oriented. Now I expect that you people are aware about what is a recall. Okay, a model should be able to recall also precision and recall, right? At the start also I try to talk about it, right? Precision, recall, F1 score. F1 score is basically harmonic mean between precision and recall. So RUG is what? Recall oriented understudy for gisting evaluation. It's a set of automatic evaluation metrics used to measure the quality of text summarization, text generation by comparing the model generated text versus the actual text. If recall focused, it is recall focused, unlike BLEU, which is precision focused. So you see it in case of classification models, what used to happen? We were getting precision and recall. And instead of that, what we have here is BLEU and RUG. Okay. Why RUG is important in LLMs even? Because RUG answers how much important information from the reference text is captured by the model. How much important information from the reference text is actually captured by the fine-tuned model. Usually used for what? Text summarization, LLM fine-tuning, research papers, benchmarks, instruction tuning, domain adapted models, and so on. And you see again, there are different types. RUG 1, it is unigram. That means 1 gram. That means it will look out only for one word. Evaluate content coverage. See the example, still if you are not able to understand. Let's say original data says AI improves healthcare and prediction says AI improves medical care. So you see everyone, it will look out only for this overlap, AI, and then it will look out for improves. So 1 gram we call it as good for basic semantic coverage. RUG 2 is what? It measures by gram. Okay, higher the value better. Okay, again, higher the value better. RUG 1, RUG 2, and so on. Two word sequence overlap. That means it will check out two words. It captures fluency and phrase level similarity. So you see, machine learning models is a reference data, let's say. Machine learning systems is the output of the model. So the overlap you see again, machine learning. So indicates better linguistic quality. If you are aware about linguistic quality, everyone, right? What is the meaning of linguistic? If you understand it, right? It will make more sense. Okay. And RUG L is nothing but what, everyone? Longest common subsequences. See, this is something which you understand, everyone. All the problems will be able to solve easily. Going and getting just the output is something which anyone can do that. Interpretation. Interpretation is something, everyone, which is very important. Okay. So RUG L based on longest common subsequence. So consider a word order and sentence structure. See now how it is going to help you a lot. See this. Now see, here everyone in this case, let's say the reference data is the cat sat on the mat. Okay. Now the prediction, the model is saying after fine tuning, the cat sat mat. So you see now the cat sat mat, the longest subsequence which it was able to recall from the original data. That is what RUG L will talk about. That means higher the value of this, that means your model is also even taking care for linguistics. And that is what we want, even. That is what we want, right? So best for sentence level structure similarity. Okay. And these are the RUG score variants which I have told you. Have a look at it. Recall how much reference content is captured, precision how much generated content is relevant, and F1 score balance between recall and precision, because F1 score is nothing but what? Harmonic mean between recall and precision. Okay. And you see everyone, for your reference, the values are also given. Score range is always 0 to 1. Higher score, better overlap. That means one thing you need to remember: higher the value of recall, better the model fine tuned. Okay, better fine tuned model is. If it is between 0.2 to 0.3, weak. The model is weak. 0.3 to 0.4, acceptable. 0.4 onwards, strong summarization. Basically, the most common use case for which it is used even is summarization. Okay. And finally, everyone, I here compared all these models, all these metrics: BLEU, right, RUG, and perplexity. So BLEU focuses on precision. It is based for translation, text generation. RUG for recall. It can be used for summarization, instruction tuning, and perplexity is basically probability. Probability, you understand, right? Chance. language modeling, quality, that is what it is going to focus. Okay, fine. And rug 1, content understanding, rug 2, fluency, phrase quality, and rug L, structural similarity. Okay, so rug is a recall oriented evaluation metric. This we have already discussed. Let's start to come to the end of this one now, everyone. Say this. This is what I have already explained it to you now. I'll go here, I'll check out. Okay. So perplexity now, it measures uncertainty in the prediction. Lower the perplexity value, better the model is. Okay. Remember at least that. Human evaluation, everyone recommended always fluency, relevance, factual correctness, depending on the problem statement. Okay. Especially importance in academic context, definitely. Model optimization techniques are also there even. Quantization, pruning is nothing but what? Cutting. Those who are aware about something like decision trees, even if you are aware about decision trees, you must have come across pruning. Adapter merging, prompt compression is also there. Prompt compression means you just reduce the prompts. Deployment options, again, you can actually use local CPU, GPU. API based deployment is easy. You can use a lot of different platforms. And containerization, if you are aware about, you can use that one as well. And yes, fine tune model, go to API and you can actually have a client application. Going and creating client applications is very easy, everyone. Nowadays, you have a lot of applications. Streamlit is there. You go, you create Streamlit app, you use the model in the backend, and then you can deploy it on Streamlit Cloud. For Streamlit Cloud, you don't require credit card, debit card details. Okay, simple. If you want to see someone, if you want to go and check out how the deployment is basically done, even here I have shown. Here also I have shown. By chance, if someone is interested, definitely yes, you can go and you can check it out. Okay, in the playlist itself also you'll be able to find this. But if you want to go and if you want to deploy it on some cloud like AWS or Azure, you'll have to go and create the account, credit card, debit card details, and all that stuff you'll have to give it actually. Okay, so key takeaways from this particular discussion everyone is what? LLM fine tuning is practical. PEFT makes it practical. Data quality is critical, and evaluation and deployment are essential. Fine tuning complements RAG, right? Retrieval augmented generation. And yes, everyone, that is fine. Yes, okay. Anyway, I think people are leaving, maybe just sitting for 3 years. I understand, not practically possible for everyone. That's why I will also close as early as possible. One last thing, can you go for some questions, everyone? Can I share one set of questions with you? Is it fine, or do you want to go through some questions? Actually, I planned it. It hardly requires 15 minutes only, based on our entire discussion, everyone. This thing, all of you, something like this one. I think we have 15 minutes, right? So for those, it is possible. I hope we can go through this, right? I'll close this. Okay. Hardly it will require 5 minutes even, not more than that. But yes, the questions are actually based on whatever we have discussed. So I will also get an idea that fine, you got at least few important points you are able to understand related to fine tuning, specifically related to fine tuning. Can you just scan this review? Or if it is not possible, tell me, okay? For those, it is possible, please scan this QR. These questions are based on our entire session. Okay, so I think we have some time. For those, it is possible. Just please join as early as possible. Okay. Thank you, everyone. Thank you. If you have any question as well, just let me know and join it fast, all of you. It will take 5 minutes only, everyone. Not more than that. Others, by chance, if you are not able to, because I understand it's office time, office leaving time now, I can understand that. But fine, for whomsoever it is possible, please join. Okay. Thank you, everyone. Thank you, all of you. I appreciate that everyone is still there. Most of you actually. Those who left, maybe I can understand. Okay, fine, everyone. Those who are there, I think 8 people are there. Fine, no problem. We can start again. Just answer it fast, everyone, one by one. The only thing I wanted to do it because the questions are based on our whole discussion. That's why. When is best to use fine tuning? Okay. When is best to use fine tuning? You have 14 seconds. Okay, two people only answered, others 8 seconds, 7 seconds. I think when is the best to use fine tuning? Yes, more predictable outputs. Two people are right. Fine. Let me see who answered fast. Sharan sir, Kalpana madam, others also tried to answer, but no worries, no problem. Let's try other. Next question. What ratio should you use when you fully want to add LoRa? What ratio in one of the PPTs you might have come across? But if fine, it is wrong, no problem. At least try to answer. Okay, 10 seconds you have. What ratio should you use when you fully want to add LoRa? Obviously, if someone is learning this first time, you will have to at least go and explore somewhat. Okay, fine. One person is right. Okay, two people are right, by the way. It is one. Okay, fine. Next. What is the main advantage of using LoRa for fine tuning large models? So these are all based on our discussion here. Okay, what is the main advantage of using LoRa? Why we are using low rank adaptation for fine tuning large models? This also we have discussed. Okay, 4 seconds, 3 seconds. Okay, fine. Everyone has answered. Yes, most of you are right. So I'm happy that fine, at least you are able to understand what was the basic reason behind something like LoRa. It reduces the number of trainable parameters, right? So at least that you will take it from this discussion. Okay. What does full fine tuning involve? Full fine tuning, that also we have discussed. We even try to see the differences as well. Okay. So you have 10 seconds, everyone. Okay, answer it. So freezing all layers, only training the output layer using no. And 4 seconds you have, 3 seconds others. Okay, fine. So updating, yes, most of you are right. Updating all model parameters, full fine tuning if you talk about. These are the people who answered fast. That is good. Fifth question, anyone? We are halfway done. Why is full fine tuning considered resource intensive? Yes, you should be able to answer it. Why it is called as resource intensive? You have 10 seconds again. 10 seconds remaining. 8, 7. So just check it out, even. I hope you will be able to recall. Yes, it updates billions of parameters. That's the reason it updates billions of parameters. Right. Next question, even. What is a common risk of full fine tuning? I think this also you will be able to make it out. This also you will be able to make it out, everyone. If you know the meanings of these terminologies, data leakage, overfitting, underfitting, model compression, right? In machine learning, generally we come across this. Okay, Santosh sir is saying D. Let's see. Yes, that is right. D. Most of you are also able to answer it right. Okay, sequence is changed. 7 questions even. What is the core idea behind reinforcement learning? Reinforcement learning, one of the types of machine learning, right? So yes, like what are the, it is also related area anyway. Generally, I started basics. So I talk about reinforcement learning as well. But I think you are aware about it. What is exactly reinforcement learning? Okay. So what is the core idea behind that? Yes, I think fine. Most of you answered it. Learning through rewards and actions. Reinforcement learning is also called as feedback based learning, reward oriented learning, reward based learning, everyone. Remember that. Okay. So Tushar sir, Prasanna sir, Nanesh, Sharan sir, and Kalpana madam. Okay, fine. Next question, everyone, please check it. What does RLHF stands for? I think this is something which you must have come across in deep learning as well. RLHF, just the full form. What is the full form of RLHF? In machine learning, deep learning, you must have come across this. 3 seconds, 2 seconds, 1 second. Fine. Yes, I think almost everyone is right. Reinforcement learning from human feedback. Exactly right. Okay, sequence is same. Last but one question now, everyone. Right, Aditya sir? That was the D option. 9 question now, please check it out. What is a fun fact about RL, everyone? What is a fun fact? Okay, so D, is it your answer for this question or what? Fun fact. Have you ever come across any interesting thing about something like this? It was inspired by behavioral psychology. Six people are right. Fine, people are aware about this. Next and the last question, everyone. You can see the sequence. Now the last question, 10th question. LoRa allows fine-tuning large language models by training only small number of additional parameters. True or false? Simple question, simplest. I want everyone to be right here. I want everyone and read the question once again here. Okay, LoRa allows fine-tuning large language models by training only a small number of additional parameters. Is it true? Only small number of additional parameters. Is it true or false? I think you should be able to make it out. Okay, that's not difficult. Okay, Santosh sir is saying true. Asha madam is saying false. Sumit sir true. Let's see. It is true. Five of you are right. That's what we have discussed even, right? It allows you less number of parameters. That's why. Yes, Pooja madam. Yes. And let's see who answered fast. Okay. Okay, Mr. Tushar, Mr. Sharan sir, and Mr. Prasanna Shete. Others are also there. Kalpana ma'am, Nanesh sir, and others are also there. Okay. So fine, that was just to give you an idea about whatever we have discussed even. Okay. If you have any question, you can definitely ask. Otherwise, I think that will be all from my end even. Okay. Because I understand it's time. So over to you, madam.
Okay, thank you so much, sir. On behalf of the Department of Artificial Intelligence and Data Science, Keystone School of Engineering,
So, madam, I think you are not audible. So, can we stop
So,
here?
with this, I would like to conclude our day 4 of this faculty development program. I hope to see you all tomorrow. Now, I'll be sharing the link for the feedback and quiz for today's session. So, all the participants are requested to fill out that.
Uh, Okay, fine. I
Thank you
think.
so much, sir, again.
Okay, thank you, everyone. I think, madam, I can stop here, right?
Yes, sir, you can stop. I'll share the feedback
Madam,
quiz.
kindly share in the chat box.
Yeah, I'm sharing. Just a second, sir. I'm sharing.
Hmm.
Okay, okay, fine. Thank you, madam. Thank you, everyone. Thank you, all of you. It was very nice to talk with you. And thank you for the patience, all of you. Thank you once again.
Okay, sir, I'll share the